بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين وخاتم النبيين أجمعين محمد بن عبد الله عليه أشرف الصلاة وأتم التسليم وعلى آله وصحبه أجمعين ومن تبعهم بإحسان إلى يوم الدين. Ladies and gentlemen, esteemed representatives and valued guests joining us here at Qatar University and online from around the world. Welcome to this international hybrid workshop focused on micromobility and its impact on our transportation system. Today, we aim to explore the challenges and opportunities presented by this emerging mode of transport with the goal of shaping effective policies and operational strategies for current issues from safety and efficiency and the future challenges as well. The workshop is organized by Qatar Transportation and Traffic Safety Center at the College of Engineering, Qatar University, and the Ministry of Transport, in collaboration with the International Association of Traffic and Safety Sciences, IATS, the International Road Federation, IRF, and the World Conference on Transport Research Society, WCTRS, and sponsored by our esteemed industrial partners, Traffic Tech Company and CDM Smith. The best to start our event today is with the profound guidance of the Holy Quran. Allow me, please, to share a few verses that emphasize the value of knowledge and unity.
بسم الله الرحمن الرحيم
وكذلك أنزلناه قرآنا عربيا وصرفنا فيه من الوعيد لعلهم يتقون أو يحدث لهم ذكرا فتعالى الله الملك الحق ولا تعجل بالقرآن من قبل أن يقضى إليك وحيه وقل رب زدني علما.
صدق الله العظيم. These words remind us of our shared responsibility to seek knowledge and work collaboratively for the greater good. With this spirit in mind, let's proceed with our event today, aiming for fruitful dialogue and inspiring outcomes. It's my pleasure to invite Dr. Khalid Kamal Naji, the Dean of College of Engineering, to give his welcoming address. Dr. Khalid, the floor is yours.
بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على أشرف المرسلين سيدنا محمد وعلى آله وصحبه أجمعين. Dears Brigadier Muhammad Radi Al-Haji, Secretary General of the National Traffic Safety Committee, Ministry of Interior, Mr. Saleh Said Al-Mirri, the Director of Land Transport Planning at the Ministry of Transport, Colonel Jabir Muhammad Adaiba, Assistant Director of the Media and Traffic Awareness Department at the General Directorate of Traffic at the Ministry of Interior, Mrs. Susanna Zamataru, Director General of the International Road Federation, distinguished international delegates and representatives of the governmental and private sectors, distinguished guests and colleagues, Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning to you all. On behalf of myself and Qatar University, it's my pleasure to welcome you to this important event. Today's gathering is a testament to the active partnership between Qatar Transportation and Traffic Safety Center at the College of Engineering and the Ministry of Transport. We are also grateful for the strong collaboration with leading international associations, including International Association of Traffic and Safety Sciences, the International Road Federation, and the World Conference on Transport Research Society. It's well known that a robust transportation system is the backbone of any sustainable and resilient society. the capacity of our transportation infrastructure to adapt to evolving needs and technological advancements is crucial for ensuring efficient and safe transport activities. In particular, the rise of micro-mobility options, such as e-scooters, presents significant challenges, especially concerning safety and efficiency. This workshop serves as a vital platform for decision makers, researchers, and industry practitioners to share their insights and address the emerging challenges facing our transportation systems here in Qatar and worldwide. Our goal is to bridge the gap between advanced research conducted at the College of Engineering and real-world practices to maximize our impact. I would like to extend special thanks to our generous sponsors for today's event, the International Association of Traffic and Safety Sciences, the Traffic Tech Company, and CDM Smith. Your support is highly appreciated, and we look at it at a high value. Once again, I welcome you all to the international event and wish you all a productive and enriching experience. Assalamu alaikum wa rahmatullah. Thank you.
Thank you, Dr. Khalid. Thank you for highlighting the importance of collaboration, especially between academia and industry. Now, I would like to invite Mr. Saleh Saeed Al-Mirri, Director of Land Transport Planning Department, Ministry of Transport, to deliver his opening speech. Please join me in welcoming Mr. Saleh.
السلام عليكم، صباح الخير يا أخوان. الواحد يشعر بالفرح والسرور أنه يرجع لجامعته مرة ثانية. بسم الله الرحمن الرحيم. أصحاب السعادة، السيدات والسادة، الحضور الكريم، في البداية يطيب لي بالأصالة عن نفسي وبالإنابة عن وزارة المواصلات أن أرحب بكم جميعا في حدثنا اليوم، كما أتوجه بالشكر إلى جامعة قطر على استضافتها لهذه الورشة التي تأتي في إطار تحقيق التعاون المستمر بين وزارة المواصلات وجامعة قطر على استضافتها وتعزيز هذه الشراكة والبحث العلمي والجانب العملي وتحقيق الأهداف المستفادة من أفضل الممارسات العملية والتطوير حول منظومة النقل المصغر من خلال تبادل الرؤى والمناقشات الموسعة مع حضورنا الكريم من الخبراء والباحثين من الجهات الحكومية والخاصة والمنظمات الدولية، بما في ذلك على سبيل الذكر الاتحاد الدولي للطرق والمؤتمر العالمي لجمعية أبحاث النقل والرابطة الدولية للعلوم والمرور والسلامة. الحضور الكريم، يشهد العالم تقدما تكنولوجيا وصناعيا سريعا في وسائل النقل المصغرة، مما يدفع إلى عديد الدول لتطوير خططها لتتوافق مع هذا التطوير، وخاصة أن الاهتمام المتزايد باستخدام هذه الوسائط شكل فرصة مناسبة لتأسيس أنماط في التنقل كخيارات فعالة بين الشعوب. وأنه لا يشرفني أن أتحدث بينكم في مستهل هذه الورشة عن الخطى الواثقة التي تقوم بها وزارة المواصلات باتجاه تطوير منظومة النقل البري في دولة قطر، ويهدف إلى توفير شبكة نقل آمنة متكاملة ومستدامة، وذلك لا شك أن للدراجات الهوائية ووسائل النقل المصغرة دور هام في الاعتماد على هذه الوسيلة على المركبات الخاصة في التنقل، وتقدم حلولا مرنة للتنقل لمسافات قصيرة ومتوسطة المرونة. الحضور الكريم، غير أنه على الرغم من الانتشار الكبير في السنوات الأخيرة لاستخدام الدراجات الهوائية وغيرها من وسائل النقل المصغرة في دولة قطر، إلا أن انتشار استخدام هذه الوسائل لا يساهم بشكل فعال في التقليل من استخدام المركبات الخاصة خلال الرحلات اليومية للمواطنين، حيث يتمركز استخدامها في الوقت الحالي على الترفيه بشكل أقل في الانتقال والوصول من مكان إلى آخر، بالإضافة إلى التحديات التي تعيق استخدام هذه الوسائط في الوقت الراهن، وتظهر أن هناك العديد من التحديات الأخرى الناجمة عن زيادة الطلب وزيادة استخدام هذه الوسائط في الوقت الحالي، مثل ضعف كفاءة إدارة المواقف المخصصة لهذه الوسائط وعدم توزيعها وتوفيرها في الأماكن العامة، مما نتج عنه سلوكيات غير مرغوب فيها، مثل وضعها في أماكن قد تسبب عرقلة المشاة أو الطرق، وزيادة الحوادث لهذه الوسائط مع المركبات والمشاة. ولتجاوز هذه التحديات وتعزيز التحول إلى استخدام وسائل نقل أكثر استدامة وانطلاقا من التزامنا بالمساهمة في تحقيق الاستدامة في قطاع النقل، تقوم وزارة المواصلات حاليا بالتعاون مع الشركاء الحكوميين وجهات القطاع الخاص بتحديث خطة الدراجات الهوائية في دولة قطر لمواكبة السياق العالمي، ويهدف هذا التوافق ليتوافق مع التوجيهات الاستراتيجية للدولة والخطط الحضرية والخطط العمرانية للتنمية المستدامة. حضورنا الكريم، تشكل هذه الورشة الدولية المشتركة فرصة مناسبة لتعزيز ومناقشة بعض المقترحات ومراحل المشروع وتحديث الخطة الشاملة للدراجات الهوائية الجاري العمل عليها للأخذ بمرئيات خبراء النقل ومتخذي القرار معنا اليوم، وذلك انطلاقا من منهجنا الذي يقوم على مبدأ التعاون بين جميع أصحاب المصلحة لتضافر الجهود بين هذه الجهات. الأخوة والأخوات، الحضور الكريم، تؤمن وزارة المواصلات بتطوير منظومة النقل وإنشاء شبكة فعالة مستدامة، ومن ضمنها تعزيز استخدام الدراجات الهوائية ووسائل النقل المصغرة لتحسين نوعية الحياة وضمان الاستدامة البيئية. وختاما، أرحب بكم جميعا مرة أخرى، آمل أن تؤتي هذه الورشة ثمارها في التعاون بين الخبراء والباحثين وممثلي الجهات الحكومية في مناقشاتهم وطرح الأفكار فيما بينهم في وضع دولة قطر في مكانة رائدة في مجال النقل المستدام وفي طليعة الدول المتقدمة، مما يساهم في توفير حياة كريمة ذات جودة عالية. والسلام عليكم ورحمة الله وبركاته.
Thank you, Mr. Saleh Al-Miri, for your speech, very informative speech, and for highlighting even some issues regarding micromobility. So you already started the discussion before the first session, so thank you very much. Now we move to the first session of our workshop today. And in this session, we are targeting to address micromobility role and position in transportation systems from international perspectives. And we have three keynote presenters, starting with Mrs. Susanna Zamataro, the Director General of the International Road Federation, followed by Professor Koji Suzuki from the International Association of Traffic and Safety Sciences, Japan. And then we have Dr. Tatsuto Suzuki from University College London, UK. Firstly, please allow me to invite Ms. Susanna Zamataro to start with the first keynote address. Susanna, the floor is yours. Thank you.
Thank you. Can you put it in full screen for me? Yes. There you are. Assalamu alaikum. Good morning, Your Excellencies, distinguished guests, and dear colleagues. It's such a pleasure, really, and truly, I say it with the heart, to be in Qatar. When Qatar calls, we always respond present, whatever the difficulties. And you will understand at the end of my presentation why I'm saying exactly this. IRF is hosting a major event, our World Congress, in just 10 days. And the teams are not sleeping, literally working day and night. But inshallah, everything will be fine. It's such a pleasure. We enjoyed a wonderful collaboration with the Qatar University and the Qatar Transportation Traffic Safety Center since several years already. That doesn't make us any younger. And we are grateful as well for the support and the collaboration that we have started and we are nourishing with the IATSS in Japan. It's such a pleasure as well to exchange with the colleagues. So, shukran, thank you from the bottom of my heart for the opportunity to share on these complex, challenging issues that are ahead of us. Being the first speaker, I thought as well I would start from the basics so that we can all have a common understanding of what are the issues at stake here. And also because I saw in the program wonderful deeper presentations from the colleagues joining us today from all over the world. Let me start, for those who are not familiar with the IRF, to say a few words really on who we are as an organization. We were born 76 years ago. Our DNA is infrastructure. We were born after the Second World War when reconstruction was so What's so important, we support public, private, but also civil society and research. Since 76 years, work very closely with the United Nations since 1951. And we really work around those pillars that you see on the screen, making sure we facilitate that exchange of knowledge and expertise, as Dr. Vahel was mentioning, facilitating collaboration partnerships, which are so fundamental these days. We work on policy and advocacy, and you will see why it's so important, especially when you talk about micromobility and data statistics, because unless you measure, you will not know what you're dealing with. And a word, maybe you already are familiar with the IRF World Road Statistics. 61 years we have been doing this tremendous effort to compile data from the transport, specifically road sector, inland transport. 200 and plus indicators, 200 and plus countries, thanks to the support of 2 private sector foundations. And here again, I'm joining the thanks to private sectors supporting all these efforts all the time. We have been able to open up completely our data. They are freely available to you. And I encourage all of you to connect to the worldroadstatistics.org website to navigate through the data and also play with some of the functionalities in there to see on different indicators the trends and the comparison between countries. Fostering exchange of knowledge is also done through our committees. I'm mentioning 2 here: connected and autonomous vehicle, of course, fundamental for understanding the current evolution, but also preparing in advance, and the innovation committee, which actually functions as an umbrella type of committee that is looking at safety, asset management, more specifically, but trying to bring everybody on the table, around the table, instead of working in silos, because a lot of what we do is really a system, and we should all embrace the system thinking and perspective. Policy and advocacy, again, done in collaboration with other organizations, other initiatives, and on the screen, just 2 examples of how we work. Left-hand side is a piece of work we supported with the Inter-American Development Bank. On the right-hand side, another piece of work we did with the Sustainable Mobility for All initiative. But let's come back to why we are here today. And while starting preparing these slides, I said, let me check whether we have, what's the definition out there of micromobility? And actually, to my surprise, there's no common agreed definition about what micromobility is. We know that micromobility is an effective solution in the urban environment to resolve what we call the first mile and last mile type of problems, but also to make sure that we provide access and sustainable access when it comes to short distance travel, which means taking people out of the car, avoiding that we congest roads if it's just for a short trip, and making sure we provide flexible, sustainable, cost-effective, on demand, which is, I think, the key word here, transport alternative. I like very much this infographics that it has been created by ITDP. Not only defining, helping you understand, because there's some blurred areas when we talk about micromobility, what we are really referring to. Micromobility is scooters, bicycles, skateboards, cargo bikes, rickshaws. It's not cars, it's not mopeds. And I think some of the benefits have been mentioned right in the few speeches before me. Trying to reduce car dependence, increase access. As you can see at the bottom of the screen in the middle, the fact that you have micromobility, it increases your chance of multiplying the users of public transport, for example, and again, taking out people from the car. So I like what they say here, micromobility unlocks more city for more people. It's using better the space much more effectively. So it's a way to reduce congestion. There's a fundamental key point about health and benefits to health, because less cars, it means as well less air pollution. Micromobility contributes to healthy, more healthy lifestyles. You walk, you cycle, so you move. It's a good way and a potential solution to sort out urban logistics problems. So 1 van, 4 cargo bikes, and it helps also the user understand that famous user pay principle. Because when you pay for your bike ride sharing or for your e-scooter, you understand that there's a cost associated to the use of infrastructure and the beautiful transport that you are using, and probably makes you think a little bit better on how you should move. And also these different types of micromobility are complementary to each other. And so they can appeal to different user groups, although we know that in general, for example, e-scooters is male and it's a young generation. But yet an electric bike can help move older people like me, who doesn't have the courage to step on a e-scooter anymore, and takes me maybe to the public transport or helps me, getting my groceries done. Now, I was looking again to some of the definitions. The CAE gave a definition, tried to pull together a definition in 2019 on what exactly micromobility is. And you see it's powered bicycle, powered standing scooter, powered seated scooter, powered self-balancing board, etc., and etc. And then they even gave a specific different classification when you look more into that, in what e-bikes exactly are. And I encourage you to take a look at their taxonomy because it's really interesting. Now, an interesting fact is when you take that and you compare to the definition which is given by the International Transport Forum, you see that there they made an effort to go a little bit into more the specific. And why? So they started looking, they created 4 different categories, type A, B, C, and D. And the difference you will see is, are we talking about unpowered or powered vehicles? What is the maximum speed? So left-hand side, 25 kilometers per hour, and then right-hand side from 25 and above with a maximum of 45. Because if you're passing the threshold of 45 kilometers an hour, it's not micromobility anymore, it's something else. And the weight of the vehicle. And why is this classification important? Because there are different consequences in many different ways, both in terms of environment, in terms of safety. And so there are different consequences in terms of policy and strategies that we need to put in place to address this type of mobility. We talk about the benefits at the beginning. It's wonderful. We connect people. We make everybody more mobile. But that picture on the right-hand side, especially for people like me who live in Europe, it's a painful reminder that, yes, not everything is shining and easy. There's quite a number of issues problems or challenges connected to micromobility. I think Dr. Vahel and many of you also mentioned the safety aspect is for sure the one that comes more prominently on the table. And here we just have started understanding the I would say the problems, and because I'm sitting at the university, I'm already asking you to please make sure you invest, especially because the authorities are here as well, in collecting data and disaggregated data for all this, if we really want to understand and address properly what we are doing. There's a massive lack of data on micromobility trips and crashes. And so we are at this stage not really able to assess crash risk properly. From the research existing right now, we know that most of the e-scooter related crashes involve the rider. So when there's a crash, in 93% of the time, the person who is affected, it's the rider of that e-scooter himself. Pedestrians, of course, safety is an issue. They are injured most of the time because of collisions, 30% of the cases. But look at that figure, 59% of the time, pedestrians who are injured because they are just tripping over those e-scooters that you see left like this on the right, on the photo, on the picture that you see on the right side of the screen. There's concern in our transport community about the increase in severe injuries from e-scooters crashes, and I'll explain you why. And I want to encourage you, what I'm saying is actually coming from a wonderful piece of research done by the ITF, the International Transport Forum on Safer Micromobility. It's a recent study, came out in March 2024. And it's quite interesting because the first time we really start digging into a little bit more these issues. And in that publication, that's where the picture comes from, you will see that e-scooters, for example, present greater risks in terms of severe injuries for head, face, and neck compared to cyclists. It's tiny at the top. I think I have a pointer here. I'm not sure it's working. It doesn't work. But if you see at the top, one explanation is already in there. Are they wearing a helmet or not? So if you see on the e-scooter, helmet use 6.1%. Bicycles, helmet use 30.7%. So that's already one sort of justification of why. But it's also depends on physically on the way the vehicle is designed. But see at the bottom, at the feet of that figure, admitted to intensive care, 2.1% for the e-scooters, 1.7% for the cyclist. So, from a very superficial look, we say, oh, it's almost the same. No, not really. And we need to address that. Now, when it comes to addressing the challenges, I think the teaching from the Safe System approach are what still has to guide us. So we are operating in a system. So it's not just about infrastructure or, disciplining the user's behavior or the vehicles, it's all of it. So we need to make sure that we have measures in place for infrastructure, for user, and for vehicles. From an infrastructure point of view, of course, the poorly maintained surface with potholes or irregularities, we know contribute 30–40% of e-scooter crashes. There's a clear point as well about segregating infrastructure, making sure that we provide clear infrastructure for different type of vehicles and, to the extent possible, segregated. But the study from ITF that I mentioned was also shedding some light on a couple of other things which are connected between infrastructure, conditions of when we use this micromobility, and crashes of severity of injuries. They noticed, for example, that the nighttime and reduced lighting were positively correlated with both injury and fatal crashes. 44% of e-scooters related casualties. And in Europe, for example, it's noted that at nighttime, people who were drinking took an e-scooter, infrastructure, you're not totally, fully impaired, and that's what causes some of the crashes. Again, a nice infographics from ITDP. Where can micromobility go? And if you look at the right-hand side of my slide, we know already that 20 million users of e-scooters are in Europe, and that micromobility market could be valued at over 100 billion euros by 2030. Now, if you take that into consideration, and on the other side, you know that urban mobility per se is accounting for 40% of CO2 emissions, and you look at the target that the European Union has set to be carbon neutral by 2050, it's a no-brainer. So you know that there's tremendous potential in micromobility, but we have to address core issues. The infographics is nice because it tells you, I think for me it's an ideal city. It's what we would like to see in our cities. Clear infrastructure, beautiful infrastructure for different type of users. But this infographics tells you also the importance of policy, because infrastructure is nice, but policy about speeding, the right set of speed at the right set of places, provision of suitable parking for the different vehicles are extremely important. It's a full slide, but some of the recommendations as well from these studies, from a policy point of view, from an infrastructure point of view, and safe vehicles. Again, because we operate in a system. Speed, reducing the speed as needed, 30 kilometers an hour where you have a high micromobility use. Enforcement. Happy to see police forces in the room, making sure you have policies as well around wearing helmets and the use of telematics. And I'm looking at industry here to make sure that we use technology as a tool that, you know, helps policy and enforcement as well. For infrastructure is fundamental, it's no-brainer. Maintenance, make sure also you have the right infrastructure in place, you maintain properly and work in partnership with private sector, because there's a lot of data which is being collected by these vehicles. How can that data serve as well your maintenance and management goals as well? And safe vehicles, there's still unclarity right now, there's no clear standards, and we need universal technical requirements for e-scooter design. Geofencing, so making sure that we make sure that the infrastructure stops you from speeding. And once again, data. Use technology, use whatever you have to collect data for us to be able to move forward. I think my time is almost over. Give me 1 second to just extend to you a warm invitation to join us to the IRF World Congress. It's the biggest event organized. It comes like the FIFA World Cup every 4 years. And we're bringing everybody together to exactly discuss these kind of issues. We have plenaries, 40+ technical sessions, 14 technical sessions with the major international transport organization, a ministerial meeting on decarbonization and resilience, and I'm happy to learn that Qatar Minister has also confirmed his attendance. So it's a big event, but a great opportunity for all of us to come together, discuss, and find solutions together. With that, I thank you so much for your attention.
Thank you, Susanna. Thank you for your very informative presentation. I think this basic definitions is very important, because even in the research field, we have a lot of conflicts in terms of what to define micromobility. And I believe different countries are taking different thresholds to define micromobility. Now we move to the second presenter, Professor Koji Suzuki from Nagoya Institute of Technology, Japan, and representative of the International Association of Traffic and Safety Sciences. Professor Suzuki, the floor is yours, please.
Thank you. Okay. Okay. Thank you for that introduction. Hello, everyone. My name is Koji Suzuki, and I'm professor of traffic engineering field at Nagoya Institute of Technology, Japan, and a member of IAT. We appreciate the effort and dedication everyone put into preparing in this event. I'm happy to have the opportunity to speak to you. Today, I talk about our IAT's project on micro e-mobility and the surrounding issue of low and medium speed mobility in Japan. First, I introduce International Association of Traffic and Safety Science, IATS. IATS was founded in 1974 by Soichiro Honda and Takeo Fujisawa and marked the 50th anniversary this year. IATS feature a interdisciplinary and international approach and conduct the practical and far-sighted research for contributing to the realization of an ideal mobile society. As for IATS organizational characteristics, 59 individual members, including me, tackle each research independent from Honda Business and Human Network with Honda Motors, and supporting IATS activity by dividends on stock donated by founder. IATS has 4 activities. Core activity is research project. For this, IATS members play a leading role, supporting more than 10 projects in every year by IATS budget. And the themes of the research align with following fields: traffic management, economics, environment, education, communication, safety technologies, and urban transportation. This table shows this year's research project. There are 19 projects this year. It includes topics such as SDGs, autonomous vehicle and AI, traffic accident risk due to climate change and weather, international survey, including developing country, and sustainability, walkable, parenting and education, improvement of roundabout and crosswalk, and our project related to micro e-mobility. The other 3 activities are publication, awards, and international symposium. For publications, IATS has 2 academic journals, as shown below, IATS Review and IATS Research. For awards, IATS awards annual people who have conducted excellent research and activities. And for international symposium, the 10th Global Interactive Forum on Traffic and Safety GIFTS is scheduled on December 7th this year. This year's theme is creating a traffic culture for a safety society. And IATS Research became the open access journal published by Elsevier with impact factor. If you are interested, please submit your research result to this journal. And further information of IATS is available in the following website. Please visit IATS website when you have time. From here, I explain about the background and objective of our research project. As shown on the figure, recently, various types of micro e-mobility, such as stand-up scooter, seated type mobility, two-wheel, four-wheel type, and so on, are developed and introduced all over the world. In Japan, there are safety concerns on sidewalks and carriageways for micro e-mobility, especially stand-up e-scooter existing with existing mobility such as pedestrian, bicycles, and cars. We need to discuss from various perspectives with scientific evidence. Objective of this study is to clarify the barriers that needed to be solved when the new mobility is introduced and spread, and to create road environment with safe and comfortable. Our research group consists of experts in traffic engineering, psychology, dynamics of machinery, mechanical engineering, law, and urban planning. Therefore, we can discuss conduct interdisciplinary research about micro e-mobility. Then I showed our target micro e-mobility. This figure summarizes micro e-mobility from the viewpoint of speed range and road space for traffic. Mobility on sidewalk with low speed 6 km per hour or less. There are three mobilities such as autonomous delivery robot, electric powered wheelchair, and boarding type robot for mobility support. An ultra compact electric car on roadway is a single seat four-wheeled motorbike that is classified as a minicar and can be operated with a license for normal car. We mainly focus on e-scooter, which have various matters to be considered due to both use of sidewalks and carriageways. Next, I introduce surrounding situation of e-scooter in Japan. As the spread of e-scooter in Europe progressed, the introduction of e-scooter was considered in Japan as well. From 2019, demonstration experiment on private and public lands began in various regions. After the experiment of e-scooter in various places, demonstration experiment on public road, led by Micromobility Promotion Council, began in 2020, utilizing the support system of the Ministry of Economy, Trade and Industry, based on Industrial Competitive Enhancement Act. In the demonstration experiment, e-scooter was allowed to run on public road with maximum speed 15 km per hour in designated areas and conditions. After the experiments on public road, Road Traffic Act were revised in Japan from last July. After the revision, two types of e-scooter exist in Japan. In previous regulation, e-scooter was can pass only on carriageways with driver's license and wearing helmet at 30 km per hour or less. After the revision of the law, another regulation was added that is treated as specified small motorized bicycle. The major difference is about the requirement for driver's license and wearing helmet and road space for traffic. Specified small motorized bicycle is permitted on carriageways and conditionally permitted on sidewalk without driver's license and wearing helmet. They can pass on carriageways at 20 km per hour or less on carriage mode, and on sidewalk at 6 km per hour or less with flashing green lamp sidewalk mode. Sharing service providers are trying to popularize e-scooters by utilizing vehicles that are regulated by specified small motorized bicycle. This slide showed traffic routes of e-scooter on carriageway. These figures are the first thing to note that Japan drives on the left. The top two figures are for carriageway with separated sidewalk. E-scooter can pass the left edge of carriageway. And bottom two figures are situations with dedicated bicycle paths and bicycle lane. For left hand here, e-scooter can pass both on the bicycle path and the left edge of carriageway. And right hand figure with e-scooter can pass only on the bicycle lane. This is a complicated rule in Japan. After the Road Traffic Act amended from last July, e-scooter sharing system has installed in large cities one by one, and the e-scooter users have been increasing in Japan. Service provider Loop has 9,700 vehicle ports and in 11 big cities and 20,000 vehicles, including e-bike. Along with this, several programs have appeared. Both the problem of traffic crashes and risky behavior of both on carriageway and sidewalk are coming to the surface. The figure on the left shows the number of e-scooter crashes over the past 4 years in Japan. From this, it is found that the number of crashes has increased sharply in 2023 after the revision of the law. For 2023, the proportion of after the Road Traffic Act revision is 80%. In addition, compared to bicycle crashes, on basic section is higher than that of bicycle. It is also characterized by many single vehicle crashes from statistical data, almost 30%. Considering that e-scooter will become more popular in the future, it is necessary to widely inform users of places and situations where accidents are likely to occur. The figure on the right shows the percentage of traffic arrests for e-scooter. We can see that the rate of lane violation is highest at 55%, followed by the rate of ignoring traffic light. It can be said that the problem is that e-scooter user doesn't know exactly where to run. Considering the characteristic of e-scooter crashes and risky behavior, and the assumption that the number of e-scooter users will increase in the future, it is necessary to firmly address the problems in the following situation. For traffic conflict with pedestrian on the sidewalk, it is required to evaluate traffic risk and user consciousness. And for the traffic conflict with vehicle on carriageways, it is necessary to analyze the movement of both e-scooter and vehicle at intersection. In light of this situation, our group is conducted research in the following framework. Analyze personal and social acceptance by questionnaire, conduct survey for legal system, evaluate users' movement and perception by field experiment and VR system, survey the intention of road administrator, and international comparison. Through these research activities, we'd like to show the direction in order to solve many issues for coexistence with new mobility, especially e-scooter, due to sharing on sidewalk and carriageways with existing mobility from the viewpoint of education and infrastructure. Some of these will be reported in detail by today's presenters. So please check them. And I'd like to conclude my presentation. Thank you for attention.
Thank you very much, Professor Suzuki, for your presentation and for highlighting the role of IATS. I know that in our region, maybe IATS is not well known, But EATS, they have a lot of projects and activities, especially in East Asian countries, in Malaysia, Vietnam, in that region, as a support from Japan in general to improve traffic and road safety situation to those countries. Now we move to the third presentation. Dr. Tatsuto Suzuki from University College London, UK, was going to provide us a presentation about a very interesting facility they have, which is, I think, unique worldwide. So the floor is yours. Looking forward to, please start your presentation.
Hello, everyone. First of all, thank you very much for inviting me to talk here. Qatar is really nice, and food is good, and very nice sunshine. It was 4 degrees. Fly from Heathrow, it was awful. So it's really nice to be here. I'm really happy. And my talk is basically a project work with Professor Koichi Suzuki. Also, I'm working in UCL Pearl. It's a really big laboratory focus on the people behavior. And so I talk about the risk title. And I put the name Dr. Kazufumi Suzuki because I work with him. Also, Nick Tyler is the director of the UCL Pearl and Koichi Suzuki. And my background is mechanical engineering, and I worked for UCL from 10 years ago. And our research question basically, how can humans adapt to environment? It is a key question in our research project because we need to do this every day and every new place. And when we have to do some task like just make a cup of tea, or just go to restroom, how to find the restaurant. So everything we need to adapt to new situation. For example, I'm in Qatar. I don't know the actual traffic rule. So if I want to go to somewhere by car, I need to know the traffic rule roughly. And but maybe I don't have time to run all the traffic rule in Qatar. In that case, UK driver license allow me to drive here, but I could do, but basically I'm probably very nervous. So this discomfort lead some risk to make some things happen. So that's why we really focus on something pure human behavior, also human comfort or discomfort, something like that. And this is a key diagram in our laboratory, and the center is the people, and the people have some individual capability. We have some skill, knowledge, and experience based on the previous experience. So we want to do something. It's like a daily activity. It's upper side of the yellow square box. And we live in city, and but our proximal environment is just in front of us. For example, for me, I just talking now, and where's the microphone? There's a PC, space key, some sort of thing. But people driving is where's a sign, or where should I go? How I can check the traffic condition, some sort of thing. And we usually interact with a professional environment, and it's dynamically changed. For example, we move, and for example, when I go out and go to restroom, I have to know where exactly the position of the door and corner of desk and some raised part of the floor and make sure I navigate naturally. And we basically adapt everything naturally, and we could do, but the difficulty is different. Also, our health condition is getting changed because of the health condition. And so for people say, I can do, but the difficulty is completely different. So that's why we do the experiment in laboratory hall and take a measurement and evaluation. And then we make some improve idea and so that some policymaker can change the city infrastructure. Also, some technical people develop assistive technology. Also, there another way is training, rehabilitation, and exercise make us more skill or increase the capability. So our laboratory is called Person Environment Activity Research Laboratory. This is a usual PAR. And the PAR's vision is to create a better world in which people and the environment can thrive together in a mutual, beneficial, safe, equitable, and healthy way. And this is in Dagenham, UK, and it takes almost 2 hours from Heathrow Airport. And this is inside of the vertical view of the PAR facility, and the red space, red part is a main experiment space, and the upper part is the office area, and the dimension is like side length is 100 meter, and vertical length is 40 meter. So it's a really big space. And you can see some small square in the red space, and it's a platform, and I can show you later the detail later. And in PAR, the photo is like that. So we have a lighting system to so PAR has a three key important function. First one is we emulate different type of the lighting condition, very dark, like 0.0001 lux to the 6,000 lux on the floor level, and different color, and it's controlled by LED lamp. We have a 40-channel LED lamp, and the number of the lamp is like a 400 or something, and cover all of the experiment area in LED. And we can control everything instantly, and emulate the different type of lighting situation in our daily life. Also, we put the speaker around the lab area, and we simulate the audio or acoustic condition, like a traffic noise. For example, if car is beeping, can we hear the other driver? Some sort of the test we can do. Also, the platform, there's small, the platform size, one platform size is 1.2 by 1.2. Its surface is, top surface is made by made of concrete, and 4 actuator colored in yellow support the corner of the platform, and change is a height. Also, the we make a surface ingredient is 360. So we can make different type of surfaces for the pedestrian wheelchair user or test how we can manage the different type of surfaces. Also, we test some small threshold if we can easily detect the height difference, like a 10 millimeter, 20 meter. You probably know we sometimes tripping just with a cord on the floor. So that type of research can be done in PAL. Also, we put the furniture sometimes. I can show you the last slide. Sometimes try mock up and sometimes big screen, sometimes supermarket. So a lot of the furniture we put on the platform and test with actual human subject. And we have a lot of the measurement equipment. The first thing, human movement is really important. So 3-dimensional optical positioning system, CODA. Also, we have a movement tracker, excellent. Also, shoe and grip pressure system, force plate. Also, a wheelchair instrumentation system. We focus on eye tracking because eye movement is a really important factor when we scan and get the attention from the environment. Also, physiological response is important because people say, oh, I can do. For example, if we do the experiment with all the people in UK, basically they say, everything okay, but it looks like very hard. So that sort of the thing naturally happens. So so it's good to ask them if easy or not, but we focus on more detail for the physiological level. First one is like sweating, also heart rate, also brain activity, EEG and FNAS, to see if people is really hard or feel comfortable. Some sort of the measurement we can do. So e-scooter. So coming to e-scooter situation in UK, private e-scooter are not allowed to be driven in public area at this moment. So only a rental e-scooter can be driven in UK now. And regulation is like maximum speed is 20 kilometer and need full or provisional driver's license. Helmets are not recommended, but not mandatory. Insurance required, but it's provided by e-scooter operators. Later, e-scooter can be used on road, cycle lane, but not motorway or pedestrian footway. Also, e-scooter does not need to register. And but we are really concerned about the safety of the e-scooter. So we have some collaboration work with e-scooter people. So first one is so one of the problematic thing in e-scooter is the sound of the e-scooter is really small, and it's really difficult to recognize when e-scooter is coming to me, coming to us, and it makes surprise when we realize the e-scooter approaching to us very end. So one of our idea is to put the sound in e-scooter and make more detectable. And we tested the basic thing and how we can easily detect the sound in some sort of noisy environment. And a yellow square in the left side bottom is a person sitting upper side, and the sound coming from the small square is the back side of the participant, and we randomly change the sound, and participant just push the button when they realize a new sound. And from the basic experiment, pink noise, like a hitting wave in the beach, heartbeat, some sort of the noise. Sorry. Right. And the hi-hat sound, like a drumming hi-hat sound, is a really detectable. And we tested it with it's actually e-scooter, right side from back. Also, I support the data analysis from a Japanese study with Kazufumi and Koji, and it's published in Yat Research. And we just test how people avoid the e-scooter when coming from front. And also, we take the measurement of the discomfort level by questionnaire. And this is a trajectory of how people avoid the e-scooter. Also, right side is the discomfort level. Red is really bad, and blue is okay. We don't have any comfort. And expect some discomfort level by equation. It's a bit, roughly speaking, we just do this case, and it's a bit difficult to adapt all of the cases, but this is first challenge. And we say we have some rule, something like a rule. It's based on the human people feeling, have some discomfort level when e-scooter is coming. And also, e-scooter simulation study in PAR, we have a set different type of road condition, car traffic, and test it with 7 participants. And there's 18 scenario, and the right side is the discomfort level, and higher is bad, and the right side is drivability, higher is bad, and seems like scenario 12 is a worst case, and this is something example, and e-scooter is a middle, and the car speed is really higher, and some sort of the bit dangerous happen in the middle. That's why this scenario is not good. Also, e-scooter experiment power, it happened August this year, and the big space of the part like that, and the experiment is something similar. I showed you before in the publication, Yat Research, and we changed the lighting condition, and so key part is like a 515 lux and 5 lux. It's really a dark condition we tested. And this is like experiment situation. It's a face coming situation, and people avoiding. And this is a box approaching. And also in this experiment, we add the eye tracking measurement, and this white circle is a fixation point of the participant. And this is an example.
Yeah.
And walking, and this scooter is coming, and check the headlight.
Definitely going up there. Definitely.
It's a one. Right. So data analysis is in progress, but we roughly say lighting is really affects the discomfort level of the pedestrian. Also, interestingly, e-scooter speed is not affected much, but people say higher speed is something dangerous, but slower speed seems like this might come to me. For example, in London, the security is not good, so someone tried to pick up something. So that's why they don't like to slow speed. Also, side position, the farther away is better. Also, direction, it's tricky to say which one, because I haven't done the statistical analysis. So we do a lot of experiment, trying getting off and getting on the right, and bus condition, visibility of the bus sign, some sort of the thing. Anyway, so if you want to come to see the PAR, I'm happy to guide you. Also, I'm happy to collaborate with you. Thank you very much.
Thank you, Dr. Suzuki. Now, at the end of this session, we will have a panel discussion with the presenters. So I would like to ask Susanna, Professor Suzuki Koji, and Professor Suzuki Tatsuo to please come to the stage. And I appreciate if you can sit exactly under your Susanna, Koji. Bismillah. Okay. Thank you for your very interesting presentations and very informative. I believe there are many questions, so from audience, I will start with one quick question to each, and then we can open for anyone would like to ask any question. Firstly, Susanna, you presented a lot about the definition of e-scooters or in general micromobility and the very different regulations that have been implemented worldwide. And I can see there is a trend to push micromobility modes, especially what we are targeting today is e-scooters, to be on pavement, on road. And countries, many small statistics are showing increasing on crashes, more severe safety problems. So how the trend will be, and what do you think should be done? Because I think it is policies to be implemented in this merging or conflicting regime between e-scooters and vehicles is very tough to control. So is there any strategies to come back to use to separate e-scooters back, or how is the trend is going?
Thank you, Wael. It's difficult to give a clear-cut answer. And my answer is that it really depends on the environment. There are a couple of studies, and in case studies from California, for example, where these scooters came first, actually. And so they're a little bit more advanced because they have been experimenting first and then adjusting policy infrastructure accordingly. In my presentation, I said it. When it comes to safety, if you implement the thinking behind a safe system approach, it's easy. Reduce the speed, make infrastructure suitable. So in this case, if you are riding scooters on the road, you have to make sure that it's segregated, really segregated. It means that you avoid that discomfort that a professor was mentioning about the big bus. You also, I think, had it in your presentation where there's a picture of a big bus and then a person standing there with the scooter. We need to avoid that. And there are ways of doing that. reducing speed is fundamental because the lower the speed,
Vehicle speed.
yes, all vehicles, basically. If it's a bus or car, so engine-powered type of vehicles and scooters, e-scooters as well. And the enforcement, I think, policy in that respect. So while coming here, I was taking a look at what was being done in different countries, and you find some of those examples in the study that I mentioned. And it's interesting to see that some of these countries who have second layer kind of experiment are now going, first of all, we open free and we experiment. And now we are going into registering the vehicle, avoiding it to make sure that it doesn't ride on sidewalks where the pedestrians are, unless you're able to really segregate and separate the two type of mobility. And the third one is about limiting the age, 12, 14, 16. There's some countries where you need to have 18 and a driving license before you're able to take one of these, to hire one of these e-scooters. So it seems to me that the trend is about there. It's fixing the infrastructure and tightening up a little bit the policy when it comes to access and type of use of these vehicles.
Very interesting. So we extend the same question to Professor Suzuki Koji. In Japan, you presented that there was the first act of law regarding micromobility and e-scooters, and it was a little bit easing the use. In the second act, there was more strict regulations. So licensing is enforced, helmet is enforced, and the usage is mainly on road with vehicles. Now, how much was this feasible to be implemented? And was this a big burden for authorities to issue licenses, to enforce helmet? And what about private e-scooter, which is not registered and being used? Is there a real enforcement on that? Can you give us the experience on implementing these laws, please?
Yeah, in Japanese law, user can pass on not only road but also sidewalk, conditionally speed limit change. And but major difficulty in Japan now, I think the user's perception of about e-scooters speed limit is unfamiliar with other persons. Not many persons not familiar with the rule. Yeah, speed limit rule. So we need to try educate the rule deeply, and especially young people, to have possibility in riding e-scooter.
For example, in last summer, I was in Japan,
Yeah.
and I was in Nagoya, and I saw many e-scooter users, they are not enforced with the helmet, for example.
Yeah.
So how this can be enforced, knowing that it's very important for safety? Is there an enforcement, strict enforcement on usage of helmet, for example? And there is a check for the license, or this is still is a difficulty to enforce?
Yes, very difficult.
difficult.
Yeah, to enforce the users. And e-scooter riders permit without helmet now. Only recommendation. So, and same problem for cyclists in Japan. Yes. And so the importance of helmet wearing helmet is we teach. Yeah.
Try to increase the publicity
Yes,
by
publicity,
awareness,
yes.
but not by enforcement.
Yes, not enforcement.
this, along the same issue in UK, you mentioned, Dr. Tatsuto, that private e-scooters are not allowed. But I read a lot in papers that everyone has a private e-scooter in UK. So there is a mismatch between, so is it really not allowed by law, but everyone has it? So this is not enforced. And this is causing big problems in UK now, in London, regarding this. I don't know if we can call it illegal e-scooters that are jumping and running everywhere. Is this being addressed, and is there any change in the policies regarding that?
I think at this moment we are still under discussion because the Department for Transport is really careful thinking on how we implement the legalization of the e-scooter. They are really concerned about the e-scooter safety, but the actual situation is, as I well said, lots of the young people are driving free in public road, and that's why some complaint to come to us, and they're really dangerous. That's why we make a project. Some sort of the situation we are seeing in UK.
Thank you. So maybe we open for public now. If you have any question and would like to ask.
السلام عليكم.
عليكم السلام.
أول شيء نشكر جامعة قطر ووزارة المواصلات على هذه الندوة اللي احنا أصلا نتطلع أن يكون في عندنا يعني مثل هذه الندوات اللي يعني احنا في طور احنا نطور عدد من التشريعات والقوانين اللي فيما يخص أي مركبات سواء سكوتر أو غيره. أنا استمعنا الشرح بتكلم باللغة العربية. I speak in Arabic because my language is not very good. زين أنا بسأل السيدة سوزانا، هي تكلمت قبل شوي عن موضوع القوانين وموضوع سكوترات. يعني أعتقد أن لازم نراعي أن في هناك سكوتر كهربائي، أيضا هناك سكوترات غير كهربائية. سكيلز اللي فيها تختلف. نفس السيارات الكهربائية فيها مثل ما تفضلت قبل شوي الجمب، يعني في القيادة أصلا حتى المهارات الخاصة في الكهربائي تختلف عن المهارات الخاصة في الدراجات الاعتيادية، لأنها يعني تجي مع التركيز في عدم الانطلاق بسرعة زائدة. الشيء الثاني أنا ما أبي أطول كثير. الشيء الثاني إحنا نقول بالنسبة للسن، طبعا كل البروفيسور أيضا والدكتور تكلموا عن السن أو العمر. الواقع أنه في فرق في بابليك سكوتر وفي برايفت سكوتر، والكل عنده برايفت ولا حد يقدر يمنع بيع البرايفت، وفي أمريكا أكثر من الدول الثانية. إحنا نقول ليش ما يكون هناك قوانين تنظيمية سواء للسكوتر البرايفت أو سكوترات البابليك، وبعدين تقدر تنظم عليها اللي هو الرخص. يعني أنا مستحيل يكون عندي سكوتر مكتوب عليه العمر من 3 إلى 10 سنوات وأخلي واحد عمره 13 سنة يسوقه، هو أصلا ما يتحمل. لكن أقدر أحدد نطاق يعني استخدامه في أي مكان ثاني أو غيره. احنا نشكرهم مرة ثانية ونشكر جامعة قطر والأخوان في وزارة المواصلات، وشكرا لكم إتاحة الفرصة.
شكرا على واجب سعادة العميد. So the two questions. The first question is to Susanna regarding laws and policies. So you know, there is electric scooters and there is also non-electric scooters, and the associated or the needed skills to drive any of them is different. So is there any laws that can distinguish the use of these scooters from that scooter, and even in terms of speed and in terms of place to be used where? Is there any distinguishing between these worldwide, or they always deal with them as one vehicle?
There's actually a lot of discussion at the United Nations, especially within the Working Party, who is in charge of setting the standards internationally about this, and there's still not clear agreement Exactly. This is still not clear, but indeed, depending on the weight and speed that the vehicle can achieve, there it's where policy starts changing, of course. The heavier the vehicle and the faster it goes, the bigger the risk of high injuries, both for the person riding the scooter or the micromobility vehicle and the other people as well. So it's still in discussion, and that's the problem. So if you look at that publication I was mentioning, you will find some references of who is doing what and how they are trying to distinguish in between the countries. But it's not 100% clean, and there's no international standards as far as I know. I might be wrong. For the moment, they clearly set, and that's why my recommendation, and in the recommendation that comes from ITF, let's make sure that we have at least one universal standard that then, I think I understood you were referring to the different municipalities, because that's the thing I was saying. We need to have a common framework that sets a little bit, the minimum basic, and then adjust it according to the local circumstances, because not all the cities are the same. And so we need to address that.
Thank you. Another question, I think it's open from His Excellency for all presenters today regarding age. So we know that the age is different from different countries, but if we take those countries who allow officially to use e-scooter from 12 years old, for example, the weight, the size, the shape of the e-scooter allowed per age could be different. How we can legalize that? And if you have a private e-scooter for your older brother, which is a big, heavy, and you in 12 years old, it's difficult for you to drive, but you take it and you drive it, and you can get hurt or you can get in a conflict because of using a scooter that doesn't fit your body. So how this can be legalized? Is there any efforts to also framework this or anything about it?
Again, in that study, there were 3 sets of recommendations, and one was specifically for standards around the vehicles producers. Right now, it's still one company does one thing and one the other. Because on the basis of the research that is available, they also understood that if we are able to all agree on a certain number of criteria for vehicle specifications, it would help a lot the work of the authorities as well. I personally, as a mother, I would forbid access to these his scooters from 14. For example, in Italy, where I come from, you must be 14 before you can drive a moped. And I would personally put a stop in there. And I was curious to make a quick raise of hands of how many of you think that we should set a target in terms of a minimum threshold in terms of age, whether we should make helmets mandatory or not, and whether we should put a plate in all these vehicles or not. I'll be interested to make that raise of hands exercise later.
Yes, thank you. Dr. Khalid?
For the audience, I can ask later, but if you can ask now.
Okay. Anyone would like to have any question? Where?
Good morning. This is Engineer Amna Said from the Public Works Authority, Ashghal. Since we're focusing on developing the infrastructure, mainly those kind of planning, it comes like already from the Ministry of Municipality. Transportation, I'm sorry. Okay, so in that case, since Ashghal already invested a lot on the infrastructure itself and building the infrastructure, how do you think like we can plan it for the future to make our infrastructure flexible to adopt any kind of changes that would be like considered under implementing those sustainable approaches on the transportations? Thank you.
So anyone would like to answer how we can make our infrastructure more flexible? Today we have scooters, we have kickboards, so tomorrow we don't know what we will have. So how we can make our infrastructure more flexible to adapt emerging new modes of transport?
I don't want to monopolize the floor, but
You want to ask, Elsa, how we can make our infrastructure more adaptable to new transport modes?
We need to develop yeah. And depending on speed range, I think if the lower speed, we need to share with pedestrian and new micromobility.
Okay.
Yeah, I think so, depending on speed range.
So speed should be a kind of main criteria to design our roads based on shared spaces. So if a limited speed, you can share different users. And this is, I think, what Professor Suzuki is clearly mentioning. Anything else? Yes, please.
From the point of view of mechanical engineering, the speed is a really important factor because the energy of the vehicle is getting higher because of the equation in physics. And also from the research of the human behavior, how we can manage actually. For example, the training is probably key part, and because if we getting used to anything, we probably very comfortably do, and it's probably safe. So this is a really important part, and how training works, and it's depends on the people. And so for me, it's good to focus on the people's capability. That's why I would like to say people is a really key part.
Thank you.
my answer would be pavement. If you look at it from a pure infrastructure basic thing, make sure your pavement is properly maintained, because whether you're walking, cycling, you're driving a car, or whichever type of vehicle, that will make a huge difference. As an operator, of course, you say, okay, but today you're asking this and I provide this infrastructure, tomorrow you're coming with something else. I understand that. Again, here we're talking micromobility, which is urban environment. And why context is important? Because here in Qatar and in Doha, the roads are very large. Where I come from in Geneva, everything is tiny. So, what is an urban road here is a highway where I live right now. Private sector comes into the picture in the sense that technology can help you also manage and adjust that infrastructure differently. The furbishing of the road, so bollards, markings and signalization are fundamental to make sure that you adjust your infrastructure in a very flexible way. And we saw that during the COVID, for example, in Europe, that suddenly people couldn't take public transport. We repurposed some of the infrastructure for bicycles, and that movement is staying. What helped that? Bollards, signalization, proper markings, and the technology. And here you have the advantage of technology. If you use it properly, it helps you use the infrastructure differently sometimes, not even needing too much investments on extra furbishing. And then, there's some case studies from around the world where even large pieces of infrastructure, you create buffer zones to make sure that fast, heavy traffic stays on one side, you have a buffer zone, and on this side, you can walk, cycle, or use micromobility.
I would suggest you stay till the last session. Our colleagues in the Ministry of Transport, they are going to talk about Qatar Bicycle and Micromobility Master Plan, where they are tangling to establish this kind of flexible, adaptable road environment in Qatar to handle all different modes. But I think key, we always teach our students in transportation courses, what we call it self-explaining roads.
Yes.
So the road should explain itself by itself. A very wide road, and you put a speed limit of 30 or 50, it cannot match driver expectation. When it cannot match driver expectation, then you will see this variation between actual behavior on the road and intended behavior by authorities. So roads has to be explainable from its design and infrastructure how it should be used, rather than only by enforcement or signs. So our roads should really explain by its design. And I think we stated the last session, you will see very interesting information about that. Dr. Khalid has an interesting, I think, question, please.
I noticed between the East and the West and the the Federation and the Research Association that the difference in defining the micromobility, you are based on the speed, but you are based on the speed and the weight, and I believe the weight is very important, and this will include the shape and the other part. So is weight considered to be in the classification or not?
Wait, it's considered
Yeah.
Japan?
Japanese regulation weight can be considered, and the size width and length and vehicle weight can consider. Yeah.
I believe in Japan probably they will have the third act in changing the regulations, because enforcement is not very easy on helmet use, licensing, putting a lot of pressure on authorities. They have licensing of cycling. So already the system capacity to adopt all these is challenging. It's a new mode in Japan. I believe the spread of e-scooters is expected to be high. Not very high compared to other countries, because Japan is an Asian country. So the probability of elderly to use e-scooter is not very high. So mostly between young people. So it's a little bit different issue than when we, inshallah, to talk in the next session about Qatar. I know that we are exceeded the discussion, but we will take 3-4 minutes only, because I would like to ask one important question to all our invited speakers. Based on current research, and as Mr. Saleh mentioned in his speech, micromobility, e-scooters are not replacing cars. All studies showing that they are not. They are simply used by young people and replacing active mobility. So they are replacing walking, they are replacing cycling. So the expected impact on the long run on health is not positive. So the question goes back, do we need to increase and put policies to encourage and facilitate the use of these modes, or we have to limit them and somehow restrict their usage? I think this is a very important question, rather than looking on the main problems we are facing, to help them, and after 5 years, we'll have a bigger problem. So anyone would like to ask or answer on this, I think.
I disagree with you, actually.
Okay. Very good.
I disagree with you. It's clear that we still need a lot of research. We're just starting to see starting to understand. And context is fundamental. If you look at the case of California, you will see it's studied with the young people because it's fashion, it's fast, and etc. But when people of my age, 50 or 40 plus, studied to use and test and understand the benefit of having a chance to move without, spending a lot of money and being stuck in the traffic, you see that it's moving. In Europe and congested cities like we have, there's no way forward. I mean, it's either you have massive investments of public transport, which still has to be done. But even that, because of investments and capacity, it will still not be enough. So you need this type of micromobility to complement the public transportation system, simply because our cities are unable to cope with more vehicle traffic from many different points of view. Space, there's not enough space anymore. And I see it in Geneva. Geneva is small. The little traffic, because we have a lot of vehicles incoming from France, so people coming from the border to work every day, daily, into Geneva, that creates a lot of congestion. It's saturated. A new train speed train line in between the two countries and a major commuting route for daily work trips, congested already. So
Is there any data for that? I read several very good papers in UK, for example.
yeah.
Simply share of cycling is reducing, shifting to e-scooter, and mainly for young generations. So young generations who are active to cycle, to walk, they are becoming liking to use the e-scooter. It's easy for them, less movement, less
It's the
effort.
e-bikes. The e-bikes are making the difference. So if you come to Geneva or in general in Europe, the e-bikes are making a difference because if you're older, you don't need to pedal a lot. So you're not, and so it has given freedom and mobility to people who would not dare to take a bike before. So it really depends. I think it's too early to draw a line, a conclusion. I would suggest and really encourage here, I mean, in a university environment, it's extremely important to deep dive again into data, behavioral, fundamental type of research, and the vehicle part, you know, back to basics and mechanical
Study.
engineering and
Okay.
physics, fundamental. Thank you.
Okay, so is it okay? Or question? Any comments? Extra comments? That's okay. Yes, please.
I think sorry. Basically, I like scooter because it's very easy and convenient.
So you are a user of e-scooter?
No.
No.
But my background is in mechanical engineering, and we cannot stop new technology. And we can stop the e-scooter, but the next one is coming probably. So I think one of the good things is just allow to people to use it, and we will see. But we have to make sure that everything is safe for e-scooter, also a new thing. And this also we have a preference, but like in UK, we really worry about the health condition because obesity is a really worst problem, big problem in UK. So government seems like encourage people to walk. That's why probably, I just guess, they don't like to implement the e-scooter because they start using and don't walk. So, but I'm not sure. But anyway, but people have a different type of reason, and it's based on the preference and health condition. So I think from the academia, it's better to make a choice for the people, but we still encourage the people to walking for healthy, or maybe a manual scooter might be the good part, health and mobility issue. So that might be.
Okay,
one.
thank you. Thank you very much. Thank you for your time today. Thank you for all the comments. Access age. I can see that maybe 50, more than 50%, they like to limit the access age. Small example, you know, I used to go every weekend with my kids to cycle. Now, since I think 6 months, they don't want everyone has a scooter. They just don't use their cycling anymore because they enjoy the scooter. So the new generations and how, especially countries which are young countries. In Qatar, I think big percentage of the population is young. If you take the neighboring country, Saudi Arabia, currently in Riyadh, they have severe issues with scooters because the young generation is adopting it very fast. So we need to think about also more policy making, how this mode should be encouraged.
training. يعني ممكن يكون واحد عمره 8 سنوات يعدي يسوق اكثر من واحد عمره 35. هي the training is very important.
So we need to have some kind of programs for training. Special driving license.
When you start your driving license, like we have mandatory first aid. When you do your driving license, we are obliged to take a first aid course. You add also that part. Exactly. Yes, so that has to start in school. So for me, the way forward is both, actually. I think we deserve a coffee break, otherwise we're still here, but.
Now we will have a 15 minutes break. We will come back at 11 to start with our second session. Thank you.
دكتور امتى مغادر؟ Assalamu alaikum. Welcome back, everyone. My name is Captain Engineer Saud Al-Hamad. I'm from the National Traffic Safety Committee, and I'll be moderating this session, inshallah. And in this session, we will be talking more on the technical side of the micromobility modes, and we'll be covering the perceptions and beliefs of the users, as well as safety aspects and some infrastructure requirements. So firstly, I would like to welcome Dr. Wael Haji Yassin from the Qatar Traffic and Transportation Safety Center here at Qatar University, and he'll give us his presentation will be on the beliefs and the perceptions of users. Please, Dr. Wael.
Thank you, Engineer Saud. I will just open. Bismillah ar-Rahman ar-Rahim. Thank you for introducing me. So today I will be presenting a study about comparison of the intention to use and social acceptance of e-scooters. As been discussed in the first session, we can see that there are variant regulations, variant definitions of e-scooters, still road authorities and enforcement authorities struggling to find the best way how to manage this mode. In the back, we need to understand why people use this mode. Who is using it? To understand the status now and the expectation of future use. For that, as Susanna presented in her slides, it's expected that the share of e-scooters to grow exponentially, expected that the market of use of e-scooters increase and the share evolve exponentially. And keep in mind is that these equipment are very sensitive to technology. So any improvement in technology tomorrow might change a little bit the shape of the vehicle. New assistant systems, new features can be added, and this could contribute significantly to the growth of them in the market. But in general, we have four major issues that are facing the use of e-scooters. Firstly, from a performance view, we have safety issues. All societies are suffering from crashes, injuries, either between e-scooters and vehicles or between e-scooters and pedestrians and cyclists if they are using the sidewalk or cycling lanes. Second important issue is infrastructure. Can our infrastructure adopt these systems? And is there sufficient facilities to operate these systems? Sufficient facilities in terms of driving or riding and in terms of parking and charging. At the same time, we have a very big lake of rules, regulations, and enforcement. The rules and regulations might be different from an area to an area within the same country, and like in the United States, and might be also different from country to a country. And this is putting a lot of challenge when we talk about micromobility, because I might be using micromobility today near metro station, and tomorrow I have a flight to Vienna or to Switzerland, and then I want to use a scooter there. Am I going to use the same regulations I am used to here in Qatar, or I have to get to know what regulations they have there? So these modes are easy to use, easy to find. Therefore, how we can manage people usage and acceptability of the mode. But what we also need to understand is that this mode is significantly affected, like cycling, with weather. So the impact of weather is very important and has to be considered. And this cycle, there is still a lot of lack of research to understand how it interact with each other. At the same time, if we look to the regulations in different countries, you can see, for example, if we talk about age, countries impose 12 years old, countries impose 14 years old, countries impose 18 years old. If I am here, I am 13 years old. I know I look older, but let's assume for the sake. I am 13 years old. I'm allowed to use in Qatar. Then next day I'm going to UK. UK is only 18. I don't know the law. I will find an e-scooter, try to find it, even it's private one from a friend, or try to rent it and use it. So these different regulations put a challenge in this emerging mode from an international perspective. And somehow the same challenge was faced in Europe if you go 30 years ago about traffic signs. Countries in Europe, within the EU, they had different traffic signs. But then you reach a unified, harmonized regulations on traffic signs so that if you are driving in Paris, when you move to the borders with Germany, you can find a harmony on the traffic signs and regulations. And this is also, when we talk about micromobility, how we can unify it. If we talk about speed, for example, also the speed varied from 15 to 25 kilometers per hour speed limit. Different countries impose different speed limits. Now, if we come to imposing different speed limits in the same country, then again, how people will follow. This is a small vehicle. So it's a challenge how to adapt to this kind of new mode. If you talk about, for example, regulations in terms of where to drive, okay? Now, this is 2020, so I believe that many of these regulations have already been changed since then, but many of the legislations before was not to use it on pavement, which many countries changed to become now with pavement after they find so many conflicts with pedestrians, for example. The best ideal place to be used in cycling lanes. So this is most of the countries who has a big network of cycling lanes, they are trying to impose and try to guide people to use it on cycling lanes. But we can see green, red, different. So there is no really clear agreement on general policies. Due to that, and after collaboration with IATS, the International Association of Traffic Safety Sciences, we decided to do an international study. This international study is part of IATS project to study and compare the social acceptance of this kind of modes, especially e-scooters, in different road environments and countries and cultures. Therefore, we conducted a project aiming to gather various information about likelihood of using e-scooters and identify the area of improvement in terms of education, infrastructure, legislation, regulation that can help people to use e-scooters. In Qatar, this project was co-sponsored with Traffic Tech Company, who generously support the conducting of the survey, and later on the graduate students who completed their work on this study. And the objective looks easy, but in the background, what we want to understand is that you, as a person, you have your sense of value of this machine. So how do you value an e-scooter? So when we value something, we go to rent it or buy it. So how do we value the e-scooter in terms of its shape, speed, character, ease of movement, ease of use? At the same time, perception of the environment when we use this e-scooter. So I think about the value of this vehicle, and then the around environment where I will use this vehicle. Based in these two, I define my intention to use, and I define my expectation for public acceptance of this mode. So we wanted to study how people value this mode, how people look around the road environment infrastructure, for example, in Doha. Do you think it's fit for e-scooters? And then how do they want to use it or not? And also connected with the social acceptance of the society to this mode. We have conducted this survey with 4 countries. I was lead to conduct the survey in Doha. We have our colleagues, Dr. Miho Asano and Dr. Shibayama, who was part of this study and conducted it in Vienna, London, and Tokyo in order to compare the behavior and investigate. The road environment is different. We talk about Tokyo, for example. We are talking about a country that have a huge demand of pedestrian, cyclists. We have cycling lanes. They are usually narrow along the carriageways and in local roads, but they are not a very big network. So the density of this kind of roads is around 0.5 kilometer for each 1 kilometer square of area. If you go to London and Vienna, the density of cycling lanes becomes bigger and bigger, especially in local roads. And they are usually highlighted either by markings or by pavement coloring. If you go to Doha, we have a huge investment of cycling lanes. It is along major arterials, highways, but slowly it's going to also local areas in order to ensure connectivity and to ensure support to the cycling activities. Still, we are in progress on that, and I believe our colleagues in MOT will present their plan in the next session. Of course, as we can see, Vienna has the largest network of cycling. London, they have also a very good cycling network, but it's still lower than the density of Vienna. In terms of these 4 cities, Doha somehow is similar to Vienna in terms of population per kilometer square. When we talk about Tokyo, we are talking about second or the third most largest city in terms of population worldwide. So we're talking about almost 10 million and a density of 15,000 person per kilometer square. When we talk about regulation on e-scooters, in Tokyo, it's considered as motorized bicycle, I think. Am I right? According to the new act, it's motorized bicycle. In London, it's considered as powered transporter. In Vienna, is a bicycle, non-motorized bicycle. In Doha, we still don't have an official definition. However, in traffic police, our officers here, when they do investigation for any crash or an issue, they always consider it as a mechanical vehicle, mechanical vehicle. So somehow close to motorized bicycle, but it's a mechanical vehicle, okay? We don't have in Doha and Vienna any licensing or insurance systems, which is very different than UK and Tokyo. There is an insurance system implemented for e-scooters, and also there is a driving license being imposed. Regarding driving position, usually it is cycling lane or in the pavement with marking. For all countries except Qatar, we don't have clear regulations. But if we consider where e-scooters are introduced in Qatar, most of the areas have cycling lanes, and most of the areas have wide public space. So most of the people who use e-scooters in Doha now, they are using it in that areas where we have cycling lanes and wide public spaces. If we go to a bigger scale and we consider e-scooter as last mile trip, then I have to reach to residential areas, then the question becomes where to be used. And this, I think, what can be presented in the next session when we talk about the Qatar Bicycle and Micromobility Master Plan. Also, the type of operation of e-scooter is different. When we talk about Tokyo and London, they are station-based. So you take it from a station, you brief it in a station. You cannot leave it anywhere. But when you talk about Vienna and Doha, they are free-floating. So you can take it from anywhere based on the GPS, on your application, and you drop it wherever you want. Just leave it and go. This puts a lot of difficulty in the management for the service, and also we will see now how people evaluate this service from road users' perspectives. Generally, when we talk about Tokyo, the most issues regarding e-scooters is regarding behavior, risky behavior. Drivers or users, they are not respecting signals, red light runnings. We have illegal running over sidewalk because they feel a little bit scary to go to the road with the vehicle, so they go to the sidewalk, which cause conflicts with pedestrians. If we go to London, the major problem they have, people are owning their personal e-scooters, while by law it's not allowed. So there's a huge spread of private e-scooters causing high demand, causing a lot of use over sidewalks, not only on cycling lanes, which cause a lot of conflict. If we talk about Vienna and Qatar, it's very similar, abandoned e-scooters, no parking spaces, and safety issues. So we conducted this survey. The data we collected in London and Vienna was a little bit around 200 sample, which is not very high, but this is what we could have collect. But in Japan, we have almost 570 sample from Tokyo. And also in Qatar, we have almost 2,500. So we have a very good, comprehensive, representative sample that's being collected in Doha. This characteristics of this sample is very interesting. For example, if you take Vienna, where most of the people who collected or filled the survey were young. In Qatar, we have a very representative sample that represents young age, middle age, and also elderly. The percentage in terms of gender also very well representative to all countries. In terms of nationality, as you all expect, in Qatar, we had only 1% native Qatari, while 99% are expats from different countries. I know that this is a low percentage, but this is raised the issue that majority of the problems with e-scooters actually with international people who are more and more using the e-scooter mode. Now, if we talk about data analysis, and I will take you, we are trying to do some kind of modeling of the behavior, but I will take you some very general, quickly descriptive results of the survey. First of all, we ask, do you see e-scooter every day? Is it a mode that you observe? In Doha, for example, 70 to 80% of the people, they say, I see e-scooters every day. This means that people are exposed to e-scooters, okay? Yes, the Ministry of Transport is trying to offer the system or this service only in limited areas, but apparently they are beyond these areas now. And they are going out. So the exposure of people in Doha is very high. If we take Tokyo, for example, the exposure of people to e-scooters is low. And this is due to the limited social acceptability to the mode so far, and to the lower number of users, since it is an emerging introduction of this system in Japan. It's not for a long time. If we take to Vienna, it's been a long time. I think the oldest country within Europe where e-scooters have been introduced or something like that. It's very long. So in 2018, so it's been almost now 6-7 years where people are experiencing. So the users and non-users, somehow it is settled down. The understanding of the society about this mode, somehow it is settling down. And that's why we see that almost 60% of the users there, of the people who filled the survey, they see e-scooters and they interact with e-scooter user in daily basis. If we ask about experience to ride e-scooters, did you ride an e-scooter or not? Only in Doha, for example, 80% of the participants from 2,500, they experience or they see e-scooter on their daily life. However, only 12% almost, they are using e-scooters. So probably here we need to really look about the results very carefully. So still the number of users in Doha is not big, but their impact on the social acceptance and what we experience on our roads is high because we observe them every day. If we go, for example, to Vienna, almost 20% they are users of e-scooters. London, 25%. And when we say users, doesn't mean your main mode is e-scooter every day. No, but you use it. You like to use it. So maybe you use it 1 time per week, 2 times per week, 3 times per week, up to 2 to 3 times per month. This we call them users. They all frequently use this mode. Now, if we go to look on those who are users of e-scooters and those who are non-users of e-scooters. So when we take the data, we classify it to 2 groups. A group which says I am a user of e-scooter, and another group which says I'm not a user of e-scooter. And we try to understand how their perception of this mode in terms of their characteristics and their primary mode of travel. For example, if we take Doha, those who are users of e-scooters, their primary mode of transport, as you can see, they are transit and taxi riders. So those who are mainly using taxi or transit, metro or bus, they are frequent users of e-scooters. So they are using it somehow as a last mile. At the same time, out of the users, we have almost 9% who are daily users of e-scooters as a primary mode of transport. If you take this to different countries, we can see this percentage is different, for example, when you go to Vienna. The users are almost car drivers. The percentage of taxi or transit drivers in terms of non-users is higher than users. So somehow, when we compare the users and those groups who are using e-scooters, we have to be very careful to the location where we are analyzing. The characteristics of the public transport, the characteristics of the spatial distribution of roads, of intersections, of locations of metros, all affect my choice whether to use an e-scooter or not. Now, of course, when we ask them what is the trip of your purpose, majority of them is for leisure, except that percentage which is shown in the e-scooter as the primary mode of transport, which is 8.5% from the users. Those are users using it for their primary work-related activities. Then we tried to ask about two things. How do you sense the value of the equipment of this vehicle? First. Second, how do you think about the road environment around? In terms of infrastructure, in terms of availability of lanes, in terms of regulations, is it suitable or not? So this is two parts of questions. And then we reach to these results. We can see here we have 6 factors: safety, disturbance, driving environment, services, usability, and attractiveness. In terms of safety, interestingly, in Doha, they are satisfied. So here is 0, which is the neutral. If you are in the positive side, means you are satisfied from the current status. If you are in a negative side, means you are not satisfied from the current status. In Doha, it seems that people doesn't have issues with safety, because most of the people, they are using it where? In the areas where MOT is providing the service. This is wide spaces. They can use it smoothly. So the general public, they don't really preserve safety issues. But if you take the Green Line, for example, the Green Line in Japan, they show a very severe issues with safety, because the primary mode of travel in Japan is walking and public transport. Everyone walk. Spaces are limited. So when you put e-scooters in such an environment, it will disturb my walking activity. And that's why probably people perceive, and our colleagues maybe in Japan, they can elaborate more about the condition there. But I believe from my experience that usually sidewalks are crowded. You even, I don't know if you visited Japan, they are using a lot of walking activities, and therefore e-scooters could be challenging because people are not always following the rules to be used on the cycling lane on the road. So they go to the sidewalk, which disturb people and cause safety issues. If we go and talk about disturbance, which is the second part, disturbance. So do you think that e-scooters disturb you? What we find is that in Vienna and all other countries, they find that abandoned e-scooters is an issue. So here we have to put a very important point. Abandoned e-scooters are recognized and an important issue for all users and non-users in public regarding this kind of mode. Okay? Even in countries where they are provided as a station-based, still people abandon it in some areas, which disturb other road users. When we talk about a driving environment, when we say driving environment is what? Like dedicated space, road surface, is it suitable or not? Do you think the exhaust of gases from the vehicles around you disturb you or not? We find that in Doha and all other countries, except Japan, they have problem with, they are satisfied with dedicated space. So in Qatar, for example, they have no issues with dedicated space because the areas where they are using it, it has a big space, the big sidewalks. There is also sufficient area in public areas where you can use e-scooters. However, if you take, for example, the Green Line, Tokyo, they have an issue with space because they have no space. All the space is used by walking activities, and therefore available space is a very issue. And this is actually supports the previous results about the safety, because no space, conflicts with pedestrians occur, and this is a very big concern for road users. If we talk about services, here we evaluate the shared services by companies. In Doha, as well as Tokyo, somehow Vienna, they are not satisfied about these services. either in terms of app, in terms of maintenance, in terms of rental prices, which is said as high, and also in terms of personal security. So some people are sensitive to sharing their information when they try to rent these vehicles. Now, this doesn't mean we have a problem of security of personal information in our system. But people, road users, they are concerned about that. Probably there is no awareness in public in Doha about the level of security we are imposing on our shared e-scooter systems. This is what we need to understand. At the end, we are asking them about this e-scooter as an e-scooter. Why do you like it? Why do you use it? So we divided the question to two parts. First, usability. Do you think it's very useful to use in terms of maneuvering, for example, holding luggages, maneuvering in narrow spaces? But then we ask them about, do you like the design, for example? Is it the design, the fun, which make you really attractive? Very interestingly, we find that most of the countries, they are those who participated in the survey, they are very in favor of using e-scooters because of the attractiveness of the mode. So they think it's nice, it's attractive, okay? And this is, by the way, it's challenged because this means that in the future, this could suddenly explode and increase more, similar to what happened in Washington in US. The mode becomes very, very, very widely used. However, all countries, they have only one worry or one disadvantage of this mode, which is luggage use. So if you are going to shopping to bring luggage, probably they will not use it. Okay? So in terms of luggage use, they have a lot of concern about the system. Then, what we did is that we asked the people, do you support putting laws, regulations that encourage people to use e-scooters? So either you are a user or non-user e-scooter. Do you agree that me as an authority to put policies to make everyone use e-scooters, to encourage the use of e-scooters? What we find in Doha, for example, more than 85% say yes, why not? Put laws, encourage people to use. We like it. So we have a very high social acceptance in non-users as well as the users, both of them. Although non-users have a lower acceptance than users, which is logical because users, they are users. So they like it, of course. So that's why they are using. But non-users, more than 61%, they are ready to use. This percentage reduces when you go to, for example, to London and Vienna. However, if you go to Tokyo, the percentage becomes very small. Why? Because of the nature of the infrastructure. Very condensed, very limited space is available, no dedicated space is available. At the same time, there is big emphasis of walking and cycling. Walking in Japan is part of culture. And I can say maybe it's the prime mode of travel. That's why if you affect it, a lot of parts of the public might not be willing to comprehend this activity, to affect this activity. Then as you can see here, we have small percentage of people who don't want to use, they don't agree, they don't want this mode at all. We concentrated on these people, and we want to understand why they are against of these vehicles. And what we find is that, for example, in Vienna, it's very different from different country, by the way. For Vienna, for example, the major issue why those are rejecting the use of e-scooters, because they don't like it. I personally don't like this e-scooter. So people have their personal preference against the use of e-scooters. And that's why they are rejecting any introduction of policies that encourage it, and they are socially not accepting to use e-scooters. Other reasons is, I prefer to walk and cycle. Why I need to use a scooter? Probably for health reasons, for other reasons, their mindset is, and that's why in Vienna, the service of e-scooter is already settled down. So people already know the advantage, disadvantage, already experience it. And then many people maybe draw back and say, no, I don't want to use it. I want to walk. I want to be healthy, for example. Other very important, in also Vienna, for example, expensive to rent, and I don't feel safe. If we take Qatar on the other side, Qatar, the most important factor is for those who reject e-scooter is what? It's not safe. So those who don't want to use e-scooter, the primary reason for them is not safe. Not only that, you can see on the other yellow boxes, there is no road condition that is suitable. So the surface condition of the road is not really very good for me to use e-scooter. At the same time, weather condition. Makes sense. Those who are rejecting to use e-scooters, mainly due to the weather condition, to the surface condition, as well as the safety. If we take Tokyo, we have different cases. In Tokyo, I don't know how to drive. It became a very important factor. That's why they are rejecting it. I have no place to park or store this vehicle. So the interest in Tokyo, probably because of the aging community, they have issues of how to properly use this vehicle. We do trainings, for example, if our policy is to encourage people more to use micromobility, doing training, targeted training, as Brigadier Al-Hajri mentioned previously in the previous section, could be an effective tool to make sure everyone is using it and in a safe way. Then we ask those who are not accepting the e-scooters, what is the best we can do to make you use it, to make you happy? Most of them, they say safety. Please implement safety strategies, improve the safety of the vehicle itself, secure dedicated spaces, wider, bigger than the available spaces which is offered by the authorities, establish traffic rules, either for e-scooters or for other road users toward e-scooters. So we need traffic rules for e-scooters, but also we need traffic rules for other road users, like vehicles, what they should do when they encounter an e-scooter. So we need also to introduce that. At the same time, providing more parking spaces as an important policy towards encouraging more social acceptance of this mode. The last question we ask them, if we do that, do you become a road user or not? Do you become an e-scooter user or not? In Doha, more than 60%, they said, yes, we will become an e-scooter. This doesn't mean that actually 60% will be used, but this means just there is a big tendency, there is a big acceptance. In social studies, this is a very important indication. In Vienna, we can see that no, even if you do that, still people will not use, because people already, their mindset already settled down. They already experienced the mode for the last 6-7 years. And now they know advantage and disadvantage, and based on their preference, they already decided the best mode that fits their cases. However, if you take Tokyo, we are talking about 13 plus 25, we are talking almost about 40% of road users who can become an e-scooter user. And that's a challenge. What if this becomes, what if we assume only 10% become? 10% change in mode share is a very big and large percent. In conclusion, in Tokyo, there is a huge issue and concern from road users regarding safety, and improvement in terms of dedicated space and safety is primary to encourage the use of e-scooters. If we talk about London, the issue of abandoned e-scooters is very big and influencing a lot on people choice and people satisfaction from the mode. However, there is a big acceptance, social acceptance of e-scooters. So they accept the use of e-scooter within their society. The second, in Doha, we have a huge positive impression, I don't know how to say it, towards e-scooters and to use of this mode. But still people are raising the issue of abandoned e-scooters, not availability of parking spaces, and limited driving spaces for them outside the available areas is an issue. Vienna is a little, and this is, by the way, these countries all have a new introduction of e-scooters. So in Doha, London, as well as Tokyo, still all the discussion on policies, it's a new evolving mode. However, if you go to Vienna, this mode is what? Somehow older than other countries and settled down, which shows that people already, their mindset is fixed, which is different than other countries. Now, if you can see from all these points how we can encourage e-scooters. So our target now to merge this mode within our infrastructure to develop a system that can adopt the user of e-scooters efficiently and safely. Unintentionally, this means we're expecting more people to use e-scooter. Am I right? Maybe we don't say this directly, but this is what we expect. Then we have to ask ourselves a very important question. I asked this in the previous session because I wanted your opinion. Several studies shows that actually e-scooters is a good last mile transport mode that could support the use of public transport. However, if you take from the long run, this mode is not actually replacing vehicles and reducing congestion. However, it is more replacing walking, especially for young generations. Walking and cycling, normal cycling, which is called as active mobility. These by SDGs listed active mobility as very important to ensure health and fitness of the society within the transportation. So again, maybe we need to think a little bit about it. I am personally not sure, but what if we ended up with more and more and more and more using e-scooters within 10 years, no one cycling anymore? Is this supports our health perspective, from health perspective? So maybe e-scooters, not only e-scooter, kickbox, different micromobility modes that are more electric, could be very useful for specific sectors or groups of the society, those who are in need of such facilitate in terms of movement. But what about the major part of the society? And we can see that based on the results in Doha, for example, less than 25 years old, their acceptance is very high, almost 90% to use e-scooters. And this percent reduces as the age goes older. So this is something that we need all to explore and think about. Thank you very much for your listening, and that's all.
Thank you, Dr. Wael, for the very interesting presentation. Now we'll be talking on the regarding the risk perception and the safety impacts of these micromobility modes. And presenting will be Dr. Miho Irio Asano from Nagoya University in Japan. So please.
Okay. Thank you. Okay. Thank you for the introduction, and yeah, thank you for having the opportunity to talk about our research. Yeah, actually, my talk is also a part of the EATS project, and I'm Miho Asano from Nagoya University. Yeah, as actually one of the EATS members, I'd like to talk about this. And this is also like well, kind of like a work together with my one of my graduate students. And yeah, actually, the Dr. Wael talked about the international comparison of and the intention to use e-scooters and social acceptance. And this is a kind of like a study continuing with the discussion. And yeah, well, the title is Analyzing the Risk Perception of the Car Drivers and Pedestrians Toward the E-Scooters. And yeah, actually, when we conducted the last questionnaire survey, it was about it was in 2021 or 2022, and yeah, actually, this is the situation currently in Tokyo. This actually picture shows shared the e-scooter stations in Tokyo with by the Loop company, which is actually one of the major companies for the sharing mobility. And as we can see, yeah, this is actually in the downtown of the Tokyo, and well, the shared e-scooter depot is really widely distributed. Yeah, so actually, well, the people are quite accessible to such actually the e-scooters. And this is the situation in Osaka, which is the second largest the city in Japan. Still, yeah, actually we have the less number of the stations, but we can see at least in the downtown, it's very easy to access the e-scooters. Well, so the question is that what is going on currently, yeah, after the changing the Road Traffic Act. And before talking about that, let me also briefly talk about the situation of the bicycles in Japan, because the condition of the e-scooter is also quite strongly related with the situation of the bicycles. And this figure shows the actual trend of like overall trend of the road traffic crashes in Japan. And we have the maximum number of the fatalities in 1970. And at that time, yeah, this is actually the general trend, but at that time, Road Traffic Act was revised to allow cyclists to run on the sidewalks in order to, like, how to say, keep the safety of the cyclists and avoid the conflict with the vehicles. And actually, after that, we have actually a long story that, the cyclists are quite accustomed to run on the sidewalk, although the sidewalk spaces are quite limited. Yeah. And in 2008, this Road Traffic Act again was revised to specify who can run on the sidewalks, who are like children and elderly, the vulnerable road users. Yeah. And however, yeah, during this long time, yeah, actually so many people are quite accustomed to run on the sidewalks. And still many people actually have some violation in running on the sidewalks. Yeah. So what will happen for the e-scooters under such kind of like circumstances? And the Professor Suzuki already talked about the change of the Road Traffic Act for the micromobility. But in July 2023, we actually positioned the micromobility as a new mobility. And the shared e-scooter, mostly the shared e-scooters are actually having the speed limit of the 20 km per hour, which means that they can run on a bicycle lane, but with the specified mode, which is actually the maximum speed of the 6 km per hour, then they can also go on a sidewalk. So then we expect that such an e-scooter might have the conflict with the pedestrian or conflict with the vehicle, depending on their settings. And maybe some people do not know so much about this traffic rule, and simply they might run the sidewalks without having such a maximum speed of the 6 km per hour. So considering the habit of the cyclists, do people follow the rule strictly? There's a big question. And also, like in Dr. Wild's presentation, there are many people in Tokyo had a very big concern of the safety on the e-scooters. So today in this presentation, I'd like to talk about these two topics. And the first part is where do people intend to run by the e-scooters? And then second question is that how surrounding car drivers and pedestrians, which are not the e-scooter users, but they actually encounter with the e-scooters. How do they perceive the risk towards the e-scooters? And we conducted some surveys, questionnaire surveys for that. Regarding the first question, where do people intend to run by the e-scooters? The questionnaire survey was actually conducted a little bit before, like 2021 to 2022, before the revision of the Road Traffic Act. We collected some responses from those who has the experience of using e-scooter. At the time, actually, we had a very limited responses at this moment. And then asking that where do you usually run as a cyclist? Yeah, sidewalk or roadway for the vehicles. And then, as we can see that, the more than half of them actually tend to utilize the sidewalk as a cyclist at the time. And then the next question is that where do you intend to run by e-scooter if you do not need to mind the Road Traffic Act? And then here, the upper part is for like those who mostly use the sidewalk as a cyclist, and the lower part is actually those who mostly use the roadway as a cyclist. And then that actually the figure shows about the preferences that where to go in e-scooters. So as you can see that it is clear that, well, if the people utilize the cycling, the bicycles on the sidewalk, then they prefer to use the e-scooter on the sidewalk. So the design running position of the e-scooter is highly affected by the running position as a cyclist in daily life. So from this, we expect that we have like a high probability of such actually using the e-scooters on the sidewalk. And then, well, regarding the next point, on the risk perception by the surrounding people. So after like such actually the discussion, then we conducted this survey this year, actually after the changing the Road Traffic Act. Yeah, we'd like to clarify the risk perception of the car driver and pedestrians toward the hazardous behavior of the e-scooter and the bicycle for the comparison. And here, we would like to define that the risk as like a combination of the crash probability and crash severity. Yeah, but for the severity, it's really difficult to ask the person by the questionnaire survey. We are more focusing on the crash probability, how they feel it's likely to have the collision with the e-scooters. And we consider that the e-scooter would be like perceived more dangerous than the bicycles from the car drivers and pedestrians. And they may have some different like a structure of the risk perception towards the e-scooters. And for that, we conducted the two types of the web questionnaire survey, and towards the residents of near Tokyo and Osaka, which means that those who can frequently see the e-scooters. So the one part is the people who see the e-scooters while driving, well, in a daily life, more than once a week. And the other part is for the people who see the e-scooters while walking more than once a week. So we'd like to call it, this is a car driver questionnaire, and the other one is a pedestrian questionnaire. And this is actually the list of the questionnaire, but actually because of the limited time, so I'd like to more focus on some kind of the behavior part. So how frequently they see the hazardous behavior of the bicycles and hazardous behavior of the e-scooters, and how do they feel the crash probability with their the hazardous behaviors. So these are the questions. So when you are driving a car or walking down the street, how often do you see the bicycle or e-scooters hazardous behaviors? And these are the list of the behaviors. For example, there are some common behaviors such as a two-person riding of the e-scooter or bicycles, and sometimes the people have a kind of a zigzag driving or red light running or over speeding and so on. And for the pedestrian survey, adding to these points, we also have the question like the e-scooters or bicycles may coming into the sidewalk and not yielding to the pedestrians. And for the car drivers, some actually that e-scooters or bicycles might riding opposite to the flow of the traffic. Yeah, something like that. The second question is that with this kind of the hazardous behaviors, how dangerous do you think that you will be involved in a crash? Yeah, these two questions, like a frequency and the danger level, we asked. And well, we collected around the 600 data samples for both the drivers and the pedestrian questionnaires. And well, mostly like age group and gender are almost equally distributed. And as we expected, that also, that we collected from like a surrounding, also like surrounding area from the Tokyo or Osaka, but the majorities are living in Tokyo or Osaka. Yeah. And then, yeah, this is the first question that how often do you use the e-scooters? Yeah, similar to the question of the Dr. Weil. As we can see that more than 80% of the pedestrian questionnaire and more than 60% of the car drivers, they never driven the e-scooters. Yeah. And then, well, this is actually the plot to explain their like evaluation of the hazardous behavior. The horizontal axis shows the frequency to see the behavior, the hazardous behavior, from the score 1 to 5. The 5 is more frequent. And then the vertical axis is the perceived level of danger. How dangerous do you feel like as a possibility of the crashes? And this is like by the score of like 100, 0 to 100. And each of the plots shows the average value of the respondents. And the blue color shows the bicycles and the red color shows the e-scooters. So, and the upper right side is more dangerous. Yeah. As we can see that mostly the bicycles is actually distributed in this way, which means that we frequently see the hazardous behavior, but their behavior, they think that it's not so dangerous. Yeah. And well, these are like e-scooters. So although we see actually quite less as compared to the bicycles, yeah, of course, the traffic volume is less. So we expect that are less, but the level of danger is high. Yeah. And also, if we look at actually the type of the different hazardous behavior, somehow like red light running, RLR, or kind of like not following the stop sign, and such kind of like a traffic rule related behaviors actually considered like upper side. Yeah, more like dangerous. And well, this side is more about like a driving stability, like losing the balances or zigzagging. Yeah, they feel actually less dangerous, but still, yeah, for the e-scooter is slightly high. If we classify this by the experience of the riding the e-scooters, I mean that the drivers, well, the car drivers, if they have some experience of the riding the e-scooter, then their evaluation might be different. The green color shows actually those who never driven the e-scooters, and then the blue color shows the experienced e-scooter. It is clear that, well, with the experience of themselves, their actual perception reduces, of the danger reduces. And interestingly, regarding the driving stability part, the people with experience tend to actually frequently detect such unstable behavior. Maybe because they themselves have some driving skills, so they may easily detect some kind of like a hazardous behavior. And a similar kind of the trend we can see for the pedestrians as well. And yeah, behaviors, but actually we can say that the behavior occurring in a shared spaces is a kind of like a special characteristics for the pedestrians. And yeah, but well, like for the, again, that the e-scooter, the people tends to consider that the e-scooter is much more dangerous. And this is also like a similar kind of like a trend we can see. So what I would like to say here is that firstly, like a desired running position of the e-scooters has a correlation with the desired running position of the bicycles. Yeah, and people see e-scooter hazardous behaviors less frequently than cyclists, but they feel more danger. Yeah, and if people have the experience of riding e-scooter, their perception changes drastically. And actually, the e-scooter users, we can say that many of them are like young drivers. Elderlies do not tend to utilize the e-scooters. So it is really important to fill the gap between the e-scooter users, or especially like younger drivers, and the actually perception of the elderly. So we need to have like a good education to recognize the gap of the perceived risk by the non-users. And maybe that we also need to have like a kind of like a training to the non-users, to having some opportunity to test the e-scooters. Yeah. So, but actually that up to here, this is based on the questionnaire survey. So we also need to consider about some potential biases between the non-users and users. Yeah. So that's all for my talk. So thank you very much.
Thank you, Dr. Miho, for the very fascinating results that you presented. Now we'll be talking to Engineer Daniel Jaros from Traffic Tech Company, and he'll be presenting the inclusion of e-scooters in the SCATS traffic control system. So please, Engineer Daniel, I welcome you.
Just a small notice that please, I know that everyone is busy, maybe you have some other appointments or meetings, but please stay with us for the last session. In the last session, if you want to go to pray, you can go and come back, no problem, but please stay with us for the last session, which is an official session with the Ministry of Transport to discuss their plans regarding micromobility there, where we need your questions, your remarks, your suggestions. And also we'll have, inshallah, after that, lunch together all here, so we can communicate together and get to know our international guests from around the world. So I will be very thankful if all of you stay with us today. Thank you. Sorry.
First of all, thank you very much for this opportunity to present the company and the solution we provide. So the topic of this presentation is the role of SCATS urban traffic system in micromobility. I would like to shortly introduce the company. So for last 24 years, we delivered multiple projects on ITS field. I will point out the most important for me and for traffic engineering, which is the first SCATS system in Doha. We delivered also first ITS tunnel management system. The very important fact is that last year we opened our office in Saudi. We know that the Saudi is very growing market for traffic engineering now. Especially after awarding the World Cup in the future. So our company is providing intelligent transport system, park management system, audio-visual systems, NPR system, NPR camera system, traffic signs and traffic management, ACT systems, and extra low voltage systems. We also, which is very important, we also have traffic department that provides their own surveys and studies. So I would like to focus my presentation on urban traffic management and urban traffic control. So currently in Doha we have more than 1,000 signalized intersections. Those intersections are divided into four SCATS systems. All of them were delivered by Traffic Tech. So we have, obviously the biggest system is the one that is managed by Ashcal. The second biggest is Lusail system managed by QD. There are two minor systems also. It's Mushrib system and the one that is under implementation now in UDC in the Pearl Island. So SCATS system is an urban traffic control system. It's the most popular traffic system in the world. The main feature of the system that I will be focused later on in my slides is that the system is a real-time system, which means that every second system is controlling traffic on intersections. The very important fact is it's a most advanced system, and the first installation was in '80s. So the experience of development team in Australia is already more than 40 years. The latest study shows that implementation of the system brings lots of benefits, and the biggest benefit obviously is a reduction of travel time. So we can confirm that in our installation the numbers are very similar. So it's 28% of reduction of travel time, 25% reduction of stops, reduction in fuel consumption. That is the results of this of the previous numbers is 12%. Same with emission is 15%. It's very important to say that it's developed by a governmental entity. It's developed by Transport for New South Wales in Sydney, Australia. So it's not typical commercial product. So they develop it by their own for their reason, and they also distribute it around the world by official distributors. One of the distributors is Trafitech from Qatar. So I would like to discuss the challenges that we have in traffic lights in terms of micromobility. So first of all, micromobility traffic lights are not really regulated. So the complex trajectories of the micromobility movement, especially scooters, is not something that we can compare with the vehicles and pedestrians. So we know that scooters users, sometimes they are using bicycle lanes, sometimes they are using standard lanes. So it's something that we cannot rely on. The speed profile of scooters is also something between pedestrians and vehicles. So in terms of our traffic engineering calculation, we cannot rely on real data. So this is the biggest challenge for us as a traffic engineer to describe how this movement looks like in terms of traffic control in signals. There's a lack of historical data. As we saw at previous presentation, the scooters, especially scooters, is something new in our traffic world. So the historical data is very little. So we cannot base our current experience on the data that we gathered for last year, for last decades. It's only something that we have for past 5 years. So the behaviors of scooter users are also hazard for us. So when we are trying to regulate the phasing and the traffic control, we cannot rely really on something that is described well in the regulation and in the guideline. So my presentation is to show you some methods to improve micromobility movements on traffic lights. But before we start to improve it, we have to detect this movement. So we know that micromobility is nothing like we had before 10, 20 years ago. So the latest technology allows us to detect micromobility movement very good. And our solution is to use AI cameras. AI cameras is machine learning cameras, and the current solution allows us to even divide scooters from bikes, from pedestrians. So we can, with this solution, we can collect the data and divide it and classify it as scooters, bikes, pedestrians. We can use this data for future development, for planning, for infrastructure planning, for traffic lights control planning. Also to detect the spots with the heat maps, the spots with the highest movement in areas. So this is the first first solution that allows us to really collect the very, very detailed data. And it's not only data about volumes, it's data about speed, that the speeds of the movement during the signal program, the speeds on the dedicated lane, the speeds on the vehicle lane. So the data is very rich. I will show the data set that we are using is in the SCAD system later. Also, the latest solution detects the violation, which is, for example, red runners, the vehicles, the users that are moving on the red light. Another thing is accident detection. So if we have any collision, the cameras are able already to detect the collision on the yellow box of intersection. So there are two options to connect AI cameras to SCAD system, to intersection. The quick solution, I call it quick solution because this is the easiest solution, and it's not very costly. It's to connect AI camera to traffic controller, to traffic light controller, and it's a direct line. So we install the camera with the processor on the intersection, and using interface between SCAD controller and SCAD, we can transfer previously defined data to the SCAD system. The most comprehensive solution is to install the set of cameras and install central AI camera system. And we can connect to SCAD system with dedicated SCAD protocol, which is ITS or SCAD Link protocol. With both solution, at certain point we receive message from those AI cameras in SCAD. So what is the data set of this data set of this micromobility movement in our cameras? First, it's a pedestrian, bicycle, scooter detection in the waiting area. So we have already project here with smart pedestrians, which gives us very comfortable way to detect pedestrians in a waiting area. So with our AI cameras, we can do the same with bicycles and scooters. So whenever bicycle or scooter is approaching intersection, we can demand the green light on traffic lights for this user. The way that AI camera is doing is by tracking the movement that towards to intersections. So it's a more advanced technology than simple detection in the loop on the intersection or with the previous video detection system. The second use case is detection of bicycle and scooters and pedestrians in crossing area. So, for example, when we're running already the green light for pedestrians, bicycle, or scooters, we know that those three users, they have different velocity. So based on that, we can check if the scooter is still in the crossing area, or maybe the speed of scooter was high enough and it's already disappeared from the crossing. So we can clear we call it clearance time. So basically we can end the green light quicker than it was programmed in the controller. The next one is micromobility flow counting. So with this data set, we are able to manipulate with SCAD parameters in terms of green time for bicycles, pedestrians, and scooters. So in areas where there is a high demand for bicycles, especially during events, we can manipulate with the green time. So we can change the minimum green time for scooters. It's a typical solution for events, for the areas around parks. And with this data set, we can provide very effective green time rather than fixed time. That's the standard solution in the traffic controller. Also, we can collect the the data of the speed of e-scooters and bicycles on the intersection. This one helps us to understand what is the required clearance time for bicycles and scooters. For pedestrians, it's different. It's quite fixed and it's regulated by the law, by the guideline. But for e-scooters and bicycles, we can utilize this data to change clearance time on the fly. And potential collision detection, it's something that I wanna discuss in details. I wanna present our method to minimize the collision during the phasing interchange. So the first example is an example of collision of evacuation of a scooter in the intersection, and as we know, the calculated evacuation speed for regular vehicle lane is the speed of the speed limit on the road. So, but we all know that that bicycles and e-scooters, they cannot use a speed of 50 when they're evacuating intersections. So with this, this is very problematic for us as a traffic signals engineers, because we calculate our intergreens and our interchange between phases based on the speed profile of vehicles. So our method is to detect the trajectory of evacuation vehicle on the yellow box of the intersection, and in case of slow movement during this transition, we can block the green for collision for next signal groups in the next phase. So the method, the step by step is like the AI camera is detecting all of the movements during the interchange between phases, and once the yellow box is still once the movement is still happening on the yellow box during the interchange, we can send the signal to the controller to block the next starting signal group. Obviously, it's not for forever, because there might be some mistakes in the detection. But for example, for next 5 seconds. In our first simulation, we did it always for 5 seconds to not let it work like too freely, because we know that sometimes the detection might be wrong. But this method helps a lot with especially with on the places that there is lots of scooters users using the vehicle lanes. The second example is very similar, but it's a bit different. It's about evacuation of micromobility. So if we detect during the transition, we detect the trajectory and movement of the micromobility vehicle, we can stop. I'm sorry. When we detect the car evacuating during the transition, we can stop pedestrians, scooters, and bicycle from entering the intersection. So it's the same methodology, but it's avoiding the collision of entering bicycles and scooters while the intersection is still occupied by slow vehicles. By slow vehicles, I mean, for example, the heavy trucks or the construction equipment. So we already provide some simulation, and it shows that when we have very good quality of detection, and we can already consider AI cameras a very high quality of detection, where the detection ratio is around 98 to 99%. We can expect the minimize of these accidents to zero. By zero, I mean obviously the one that are happening during the phase transition. This method is a universal method, and we can also utilize it for different type of vehicles. So, for example, when we have a construction vehicle evacuating intersection with very, very low speed, we can also utilize this method for this type of potential collision. That's all from my side. I'm happy to hear questions later. Thank you very much.
Thank you, Engineer Daniel, for giving us a overview of what the industry is doing in terms of micromobility management. Now we'll move to our final presenter, Dr. Takiro Shibayama from Austria, and he will be presenting how the inclusion of micromobility modes in rural areas. Please, Doctor.
So, good afternoon already. My name is Takeru Shibayama, and I will bring a little bit different perspective from a transportation planning point of view, and I'm going to talk about the potentials of micromobility in rural areas, especially sparsely populated areas. And I, together with a student, we carried out a case study. So the main part is our case study, but I'm going to talk about Vienna before I go into the main part. This is about myself, but I will skip it. But the study is partially inspired by the work which was carried out as a part of the work together with the OECD's International Transport Forum. I was a member of the working group Sustainable Accessibility for All, and the report was published in June this year. And the idea was inspired partially by this working group, but also by the project which have been mentioned a couple of times during this conference. And the study is from Austria. Do not get confused with Australia. We have no kangaroos, and we are in the middle of Europe. And the capital is Vienna, and Austria has approximately 9 million population on the surface of approximately 83,000 square kilometers. And it's among the high-income countries, and Austria is a part of the European Union since 1995, and it has 9 federal states. And as mentioned, Vienna is the capital, which is rather in the eastern part of the country and having roughly 2 million inhabitants with approximately 4,000 to 300 inhabitants per square kilometer. But Vienna has a very different profiles depending on the district. So the highest density is observed in a inner city district having about 27,000 inhabitants per square kilometer. And the lowest density is observed in the outer district with having a vast forest, and it only has about 1,400 inhabitants. So the situation looks very different. And Vienna's origin is a Roman settlement dating back to the 1st century BC, and it has a very long history. And Vienna has a long history too in terms of the sharing of micromobility. So many of you have heard about the bike sharing system of Velib in Paris, probably, and actually it's a copy of the system from Vienna. Vienna had a trial between 2002 and 2003, which was called Vienna Bike, and since after this test, the so-called City Bike Wien was implemented in 2003. And it was already demolished in 2022, and it's already replaced with the next generation system. And this developed the modern information and communication technology supported bike sharing system. So it's already more than 20 years ago. But Vienna also had a very painful experience with the free-floating bike sharing. This is the picture from 2017. And some Asian companies came to Vienna, spread thousands of bicycles throughout the city, and this was what was happening. And what was more painful in Vienna is that after 1 year, in the middle of 2018, when the city government changed the regulation, they decided to quit. And one of the company left all of the bicycles on the street, doing nothing. And the authority had to clean up these vehicles, of course, on the shoulder of the taxpayers' money. And since then, there's no free-floating bike sharing. But in exchange, Vienna got the e-scooter sharing, as I mentioned, in 2018. So it has a long history. So Vienna's e-scooter sharing scheme is built upon the experience of the bike sharing, the free-floating bike sharing, which wasn't really successful. And as already mentioned, it has been already 6 years since the beginning of the e-scooters. There's a lot of fluctuations. At the peak, there were if I remember correctly, 7 operators providing the sharing. Nowadays, there are only 4, and people are starting questioning if such a sharing business is really sustainable, it really continues to the future. And as already mentioned, the abandoned e-scooters are already the problem, but also the question of the profit-making business. This is also a questionable situation in Vienna, and this is mainly because of the Vienna's transport structure. So if you see the graphics on the right-hand side, this is the change of the model split of Vienna since 1994 until 2020. And on the right-hand side, these green bars are the policy targets, policy goals of Vienna. So the policy goal of Vienna is by 2025, make the share of the car down to 20%, and make the share of walking, cycling, so the active modes, and public transport to 80% altogether. And by 2030, bring them up to 85% and car down to 15%. This is the policy goal of Vienna manifested in the Sustainable Urban Mobility Plan. And as you can see, Vienna has been reducing the share of the cars from roughly 40% nowadays to approximately about 26%, and retains the share of the walking, and also the red parts, this is the cycling. It has been increased from roughly 3% in 1993 to almost 10% in 2023. So Vienna has a quite high share of cycling. And the orange part, this is the public transport, which is reaching to 35% recently. So on the left-hand side, you see the pie chart, and this is the latest data of the model split. As you can see, Vienna has a quite high share of walking plus cycling, altogether more than 40%. Public transport a little bit more than 30%, and car about 25-26%. So in these circumstances, people are starting to question if micromobility had some space in the city. And there's a dilemma, and this poses an interesting question as well, or we can call it as a weak problem. And the first bullet point, this was a dialogue with Mr. Deschamps. He was the manager of City Bike Vienna, which I mentioned. So basically his idea came to the bike sharing supported by the ICTs. And for functioning bike sharing, it was his opinion, we would need a quite high density if it's station-based, around 200 to 300 meter distances between each stations, or potentially free-floating, but it creates some problems. And importantly, we would need a very high population density, ideally around at least 10,000 inhabitants per square kilometer. And this is only possible in urban centers, where you can do a lot of things on foot, and also on public transport, and also bicycle has a lot of potentials. And this is also the area where urban amenities, facilities, and services are concentrating. And where micromobility is really needed is indeed urban peripheries where the density is much lower, and also in rural areas where traditionally the modal share of car is very high. And this was also an interesting discussion topic in the conference, which was named WOCOMOCO, World Conference on Collaborative Mobility, back in 2018. The WOCOMOCO is unfortunately discontinued, but since 2018, we have been discussing, and there has been no practical solution. So there's a clear dilemma. So everyone, also the operators, focus on the city center, but actually the potential can be gained quite likely more in the urban peripheries and also in rural areas. So there's a wicked problem. In rural areas, but also in the cities as well, there are some public transport services which can be a backbone of the sustainable transport. And in Austria, there's a classification system called Ufergüteklasse in German, and I tentatively translate it as a public transport service quality classifications or classes. I don't go much into the detail, but the essence is that each public transport stops, so the railway stations and bus stops are categorized based on the types of the services. For example, if you have the railway service, if you have the tramway, if you only have the bus, and also the average frequency during the daytime. So you have the class in the Roman letters, Roman numbers from 1 to 8 or outside. And based on this classification, so the stop classification and the distance to the stops, the area is classified from A to G, so the 7 classes plus outside. So I don't go much into the detail, but the important is that with this classification, the whole Austria is, all surface is classified into the public transport qualification class. And the red or the orange area, these have high potential of public transport use for the residents or destinations. And the white area, this is the outside of the practically usable public transport. And as you can see, Vienna is pretty much red to orange, so it has a very high potential of public transport. So these are other cities like Linz, Salzburg, Innsbruck, or Graz. They are covered by public transport, but the real potential of micromobility is somewhere maybe here, where the public transport is somewhat given but limited, and maybe not here. This is a very mountainous area, so that we need to think about how to gain the potential of micromobility in such rural context. And what I'm going to talk about is this area. It's a very rural area, but as you can see in the slightly west of this area, the westernmost part of this state, there's a quite good public transport. This state is called Vorarlberg, having about 410,000 inhabitants. And interestingly, this rural state of Austria has 14% of mode share of public transport, which is quite high. To compare, for example, the city in Germany, Bremen, has about 17% of mode share by public transport with 600,000 inhabitants. Or the city in France, in Nantes, in France, it has about 15%. It also has about 700,000 inhabitants. So this state already has a quite extensive public transport network, and they also have a quite good biking infrastructure. The left picture is from the Vorarlberg. So you have the bike parking, and in front of it, there's a railway platform. On the right picture, this is not from Vorarlberg, in a different state, but inspired, so to say, by Vorarlberg. So coming back, in this case study area, Bregenzerwald, this is a very rural and also very mountainous area with very sparse population. There are only 30,000 inhabitants, and the biggest municipality only has about 3,500 inhabitants. It has well-developed public transport core network, so it's not this red area, but as you can see here, there are some green, orange, red areas. So the core network has about half an hour to 1 hour interval of public transport. And we carried out a case study, and as I mentioned, together with my student, we carried out this case study. And to give some impression, this is very rural. The left-hand side, this is the, so to say, the core part of this Bregenzerwald, or we can translate Bregenz forest area. It's very mountainous, and if you go there, you can see that the cows are roaming around. And as I mentioned, it has a quite good public transport. And what we did is, first, to adapt the Austrian public transport classification system so that we can capture the mountainous situation, but also successfully the e-bikes, which is also a kind of micromobility vehicle. So the upper picture is the calculation approach using the standard Austrian method, and we considered the elevation and the slopes using the digital elevation map, and then you can see how it changes. So it basically shrinks the area which is accessible to public transport. And using this, we carried out some scenario analysis. So scenario number 1 is to invest e-bikes as a feeder to public transport with more extensive biking network, and also importantly, the intermodal stations having proper parking facilities. And I think that the number is wrong. In 14 out of 22 municipalities, we set this scenario. The second scenario, that's the biggest competitor to the micromobility, the demand-responsive transport and autonomous shuttles. And we carried out some literature review, and in which municipality which is feasible with the current demand responsive transport and potentially with the autonomous vehicle. And we only could identify 4 basically larger municipalities which will have the potential of the demand responsive transport with the self-driving vehicles. And the scenario number 3 is the mixture of them. And we analyze a couple of points I don't go through, but the key result is that in terms of the public transport services and access, if we strengthen the micromobility, the public transport accessibility is improved in 17 out of 22 municipalities using this focus on the networks and e-bikes. The autonomous vehicle, the scenario 2, of course, the improvement potential is very much limited due to the limitation of these services in relation to the population size and density. And of course, the number 3 has improvement, but especially in the largest municipality in the area. It's interesting, the town is called Ek. And in this municipality, it gains the most potential. And of course, the scenario 1 and 2 potential can be gained. In terms of the needed infrastructural investment, of course, the biking infrastructure, you would need more investment to realize it. The dimension is completely different. It's about 30 times more investment is needed to promote micromobility in this rural context, because the road infrastructure is still very much adapted to the automobiles. So we need to adapt the infrastructure quite a lot. So it's a dimension of 21 million euro against 0.8 million euro in terms of the initial investment, but also we shouldn't forget that the bus transport would need some running cost. And what is important is the user potentials for public transport per year. So the scenario 1, the e-bike scenario could generate approximately 280,000 additional public transport users per year based on the current travel patterns. We just exploited the travel patterns based on the current travel survey. And due to the limitation of the demand responsive transport, this is shrinking only to 31,000 additional public transport users. If we mix them, it's of course the best option. We can generate about 300,000 additional users of public transport per year. And remember that this region only has 30,000 inhabitants. So 10 trips per person per year public transport can be at least generated by encouraging the micromobility in the rural context. And of course, in terms of the autonomous vehicles, there are still some technological uncertainty, although it's being advanced pretty much. If you go to Stavanger, Norway, for example, it's quite stably running autonomous vehicle, but we still don't know in the rural context. So to wrap up, in light of the sustainable transport, there are clear dilemmas related to micromobility. So everyone rushes into the urban settings, but the potential can be gained more in the rural area. And in this case study from Bregenzer Wald or Bregenz Forest in Austria, in rural context, probably encouraging the e-bikes, potentially also e-scooters as well, could gain better potentials to shift the people's travel demand from automobiles to public transport. And this would cost at the beginning quite a lot, but based on the well-developed public transport, we could gain some potentials in the rural areas. So this would conclude my presentation. Thank you very much for your attention. And I return the floor back to the moderator. Thank you very much.
Thank you, Dr. Takero. Very interesting application for micromobility and how to integrate them with public transport. So in the interest of getting back on track, we'll be skipping the question and answer session, and we'll combine it with the session afterwards, after the talk with the Ministry of Transport. So we'll see you back at 1 p.m. and we'll be talking with the Ministry of Transport regarding the bicycle master plan.
15 minutes break, and we come back at 1 p.m. There is a prayer room for female and prayer room for male just after the lunch area. You can access it, and we will come back at 1. Any questions you have, keep it till the end of this of the workshop today, we will answer your questions, inshallah. Thank you. Hello, everyone. We come back to our final session today. This session is a very important and very essential session since it discusses Qatar Bicycle Master Plan, which also incorporates micromobility. For that, I would like to invite Engineer Rula Khashman, who is a member of the Qatar Bicycle Master Plan team at Ministry of Transport from CDM Smith. She will be, inshallah, moderating the session and guiding us through this important discussion today. Thank you.
شكرا دكتور وائل على التقدمة. السلام عليكم. يعني أنا بعرف دائما إنه السيشن الأخيرة بتكون شوي صعبة، لكن إن شاء الله رح نحاول تكون سهلة وممتعة وفيها معلومات مفيدة، خصوصا بعد هذا الزخم الكبير اللي شهدناه ببداية الوركشوب، واستمعنا للعديد من الآراء والأفكار والمقترحات من مجموعة كبيرة من الخبراء اللي شاركونا اليوم خبراتهم المتنوعة. لكن هاي السيشن رح تكون فعلا هي سيشن مهمة لأنها رح تستعرض مشروع من الواقع المحلي بخص دولة قطر. هذا المشروع اللي جاء تحت إدارة وزارة المواصلات في دولة قطر، واللي هو تحديث الخطة الشاملة للدراجات الهوائية في دولة قطر. الحقيقة إحنا بهمنا اليوم الحضور من مجموعة كبيرة. اليوم الحضور مجموعة كبيرة من أصحاب القرار والمعنيين وأصحاب المصلحة. بنحب نشارككم بعض المعلومات عن المشروع من حيث مراحل المشروع وبعض التقدمة، وبنحب برضو كمان نستمع لآرائكم وخبراتكم في هاي المرحلة المهمة من حياة المشروع. بسم الله نبدأ. Dear guests, thank you all for your active participation, and I also would like to thank Qatar University and Ministry of Transport and all sponsors for providing this opportunity for bringing us all here together, experts, stakeholders, and all invitees to discuss this topic regarding micromobility. This session will highlight the current work on updating Qatar Bicycle Master Plan, which comes under the management of Ministry of Transport. But before we starting directly our session, I want to give a small quick brief about the project to provide some information and also to make sure that we are all having same common understanding regarding this project. I want to share at the beginning the mission of the project, which is main objective is to create an attractive, sustainable, and safety cycling environment here in Qatar by developing an integrated and accessible network for bicycles and micromobility modes through innovative planning, comprehensive guidelines, and community engagement, aligning with Qatar National Vision 2030. As I mentioned, that this project comes as one of the important or main projects to achieve the transportation plan of Qatar 2050, to achieve its visions and goals, which is to provide an integrated and sustainable transportation system that supports the economy and better quality of life while preserving national identity. The project also comes as an update for the first bicycle master plan issued in 2008. This update was very essential due to many reasons: the increased demand on this kind of transport, increase of population of Qatar, and trying to capture all the opportunities and to mitigate the challenges in this regard. The project will be conducted to ensure effective infrastructure for bicycles and other micromobility modes with the proper integration with Qatar's public transport networks. As we see here in this slide, the project has 12 main objectives, and in order to achieve all these objectives, we have or conducted certain study on some focused areas. It was regarding the plans and policies, the rules and regulations, design standards and guidelines, and the management specifications and monitoring afterwards. In order to meet all these objectives and to have a proper conducting study, the project was designed to have 7 main stages to cover all the needs and the challenges, the motivations, the barriers, and to come up with the proper schemes and implementation of the project. The first stage was regarding a desk review for the current or existing documents here in Qatar and some best practices. And then we went to the second stage, which is about the data collection, the surveys. We've conducted a survey for a sample for more than 5,000 sample here to cover the whole state of Qatar for users, non-users, to have some inputs for the study and to find out some insights, barriers, motivations for the use of bicycle and micromobility here in Qatar. And the third stage, it was to do this assessment exercise and to then have this assessment for future conditions and its challenges. All these stages were as feeders to have and to propose the schemes afterward, and then to come up with this final master plan and to make sure that the implementation and monitoring program will be set. This project also is expected to be as a tool, a policy tool and guidelines for planners, decision makers, designers, and all concerned entities, that they have this tool to have better planning for bicycles and micromobility here in Qatar, to be effective in design, implementation, and operation as well. Thank you. This is a short introduction and brief regarding the project. And now, mainly in this session, we'll discuss two main topics. The first one is regarding bicycle and micromobility policies, perspectives, and local needs. And our presenter will be our colleague, Chris Lucas. And the second session will highlight on the principles and designs, guidelines for bicycles and micromobility infrastructure. And our presenter will be Connor Simler. We'll have these two sessions, and then we'll open the floor for the questions and answers and all discussions. And I would like to introduce our presenter, Chris, for the first session. Chris is a senior project manager at CDM Smith, where he leads multimodal safety projects throughout the United States. He is recognized for the bicycle policy and design applications he developed for the New York City Department of Transportation, much of which have become national standards for street design. Chris, thank you.
Thank you, Rula. I'd like to start by thanking the local dignitaries, Qatar University, and the Ministry of Transport for having me here today. Qatar Qatar advances in many areas, and it's an honor to be a part of this project where we seek to do the same, to provide best practices and to influence the region and beyond. Policy development process is still in progress. So today, the importance of today is gathering input from the stakeholders that are here, as well as joining us virtually. And that's really a key to our success. So after our presentations, we'll have a questionnaire that will circulate to address each of the policies that I'm going to talk about now, and get your input in terms of effectiveness and any remarks that you may have regarding the work that we are doing, which is, again, in progress. So the, excuse me, the BICEL Master Plan, we're looking at policies that satisfy the 6 headline objectives: accessibility, attractive, integrated, safety, shared micromobility, and sustainability. And within that, we have looked at criteria for policies to determine whether or not they conform with the requirements of the master plan. Those are relevance to the Bike Master Plan itself and those 6 goals, alignment with those objectives, the feasibility of implementing the policies considered, the necessity of these policies, and the applicability to the context here locally. So this is an iterative process, and as I mentioned, today is one of those iterations where we're gathering input from these stakeholders in attendance to finalize the development of policies. So we've gone back and forth between stages where we're looking at policy context and then using evaluation tools, the gap analysis and best practices, and then developed a long list of potential policies, which we then applied to the sifting framework for those 5 criteria I just mentioned, where we arrived at a short list, and then we started identifying and analyzing the impact of each of the recommendations on the short list, where we began to refine and prioritize the potential policy recommendations, and then we will result in suggested policies. So we started off with a list of 44 potential policies that we developed through looking at the context again and international best practices. We narrowed that down to 24 on the short list, and then through the analysis of impacts, we've arrived at 17 suggested policies. Of those 17, we have 7 headline policies which address the most urgent needs and have the highest impact. And then we have 10 supporting policies, which will fill in other gaps in the existing context. And because there were a lot of other useful and supporting ideas, we've also have more than 20 additional accompanying schemes that we will be looking at applications throughout the scheme development as the process continues. So now I'm going to go through those 17 suggested policies. These are the policies that we will be circulating the questionnaire about and we'll be asking for your input on. So I will go through each of them, and then we'll have a chance to discuss them later on when we have questions and answers. The first one is to develop a micromobility network. So we understand that having a comprehensive, integrated, safe, and comfortable network is critical to ridership. Right? We need people to feel comfortable. And so that includes retrofits as well as strategic planning for new infrastructure and expanding the network to where the gaps exist. We also understand that shared micromobility, as we've discussed today in the context of Doha in particular, requires a more clear regulatory framework. So everything from managing areas, pricing structure, regulations for use, things like age, safety equipment, developing regulations for the operators, and then enhancing enforcement and ensuring that the regulations and the pricing scheme are communicated effectively so that when visitors come to Qatar, they understand what the expectations are and how to proceed using the network. We also understand the importance of having a uniform set of standards for safety and consistency. So Connor's going to discuss a little bit after me about design standards, and we want to make sure that these align with global best practices so that, again, as users come from other locations, they understand the expectations and how the operations work. Within the culture of transport, it's really important that micromobility has a role and that people understand how micromobility relates to the rest of the transport network. So establishing campaigns to provide that information is going to be important, as well as programs, educational initiatives, and other activities that get people to overcome the barriers that may exist to initiate use of micromobility. As we know, the climate in Qatar can present a challenge for active transportation. And so we need to make sure that we have health and safety infrastructure in place, things like hydration, shading, emergency call centers, and emergency access for ambulance stations to respond in the case of emergencies. So this is going to be a critical piece to ensure that the comfort and usability of the system is there. When we talk about micromobility, we've heard other speakers today talk about first and last mile. So integrating with the public transport agencies is very important. Everything from a unified card system that can be used for public transport, as well as other forms of public transport, as well as shared micromobility, locating shared micromobility devices at stations for easy use between modes, and providing parking with charging stations for private micromobility devices that may not be part of the shared system, which has charging built into it. Technology is also a very important feature for transport these days in general. So real-time updates for locating micromobility devices, whether they're shared or locating parking for private micromobility devices, and really integrating the fare system with other existing transport systems makes the user that much more able to access the micromobility system. There was a question in one of the earlier panels about the changing environment. And so promoting infrastructure and policy review on a regular basis so that the rollout of a micromobility network is an iterative process, so that as emerging trends evolve and best practices are applied elsewhere, we can incorporate those into the context here in Qatar. Lowering speed limits is something that is directly linked to safety. We've seen with vehicular crashes that the higher the speed, the higher the consequence. And so lowering speeds for vehicles makes it safer and provides more access to micromobility. And that again will reduce a barrier. There was a lot of research done on the perception of safety, and speed is not only a perception, but it's a reality. This will also include things like including a sound for micromobility devices, so that drivers are aware of their presence when they're nearby. Designating public space for cycling is about providing an environment where people can use micromobility maybe for the first time or get more comfortable using micromobility. These can be public spaces that are open to, such as parks that are open to families during designated times. This can also be geared specifically toward women who may want to use micromobility in a private environment, as well as considering signature projects that become sort of flagship spaces where instead of a park that's partially dedicated at certain times to micromobility use, these will be designated projects that provide full-time access to safe, comfortable places to learn and to use micromobility for leisure. Strengthening safety goals for micromobility will be looking at crash reduction. So the National Traffic Safety Strategy has crash reduction targets for vehicles and pedestrians. And by looking at a crash reduction for micromobility by its share of ridership, we can ensure that in future conditions that we have, we're looking at very specific design and policy solutions to address safety. So rather than looking at a total number of crashes for micromobility, because we do expect the trends to be increasing, ridership to be increasing, we want to look at proportional reductions for crashes, fatalities, and serious injuries. And we also want to make sure that in the event of those incidents that we have direct and easy access for ambulances and first responders, and that they can get onto separated facilities. So we don't want vehicles to be able to access wide cycle facilities such as the Olympic track, which exists, which is wider than some roads, but we do want emergency vehicles to be able to access. So looking at things like retractable bollards that can be lowered for emergency access and then raised again to make sure that vehicles don't inadvertently access the micromobility facilities. Enhancing wayfinding is very important because as you travel through the network, whether you're a visitor, a first-time user, or somebody that rides regularly but maybe in an area that you don't know as well, rather than relying on personal devices where you have to take your attention away from the roadway, knowing that there's a system of wayfinding that's going to tell you when you're on a route, when you're intersecting with other routes, and what destinations are at those junctions will be critical to allowing people to navigate through the system and feel comfortable and know that there's a clarity and consistency, and they will be told when they're intersecting, and they don't have to worry about that, gathering that information themselves as they're riding. Integration with private development is something that has started, but needs a bit more enforcement and a bit more thought behind it. Because as we develop new residential and office facilities, we need a place for people to park private micromobility devices. So making sure that that parking is available, but also that facilities that may be developed or built as part of a development connect to the transportation, the public transportation, or the public streets, and vice versa. And that if you have a public street that has a micromobility facility that interfaces with a private development, that it doesn't just stop, that it continues through, and so that you have full connectivity throughout the entire roadway network. Encouraging youth cycling is something that we see as a very important feature for future generations to feel comfortable using micromobility. So looking at things like safety around schools, and we've talked about age requirements. There may be a certain age where if you're accompanied and supervised, that it's appropriate to use micromobility. And looking to really raise awareness around schools. There is a school zone speed limit that's already in place here, but really targeting those barriers that would make parents in particular, because I know my child, he's ready to go use an electric scooter, but I'm not. So really making sure that the safety features are in place and that the speed limits are the school speed limits are enforced to make sure that the environment is safe is very important. Micromobility parking requirements, again, in private developments, we need to make sure that not just vehicular parking is required, but that there's requirements for micromobility, bicycle, and other micromobility parking that's safe. So, you know, there are certain bike racks that work for bikes and micromobility, whereas others don't. So ensuring that in private developments, you have the infrastructure that can keep these devices safe, because once you start talking about electric devices, the cost goes up, and the you want to make sure that people can have a safe place where they know that when they leave their home, it's going to be there and it didn't disappear. Expanding areas for shared micromobility deals with the current operating zones. There are several operators, and some systems are able to be used in some areas, whereas other systems are in other areas. Connecting between those areas can be a challenge. Sometimes if you leave a service area, the device will stop working. And so making sure that the areas are expanded and that there is a consistent mesh of rideable locations so that you can get from point A to point B and to all the destinations in between that you need to without experiencing a lapse in service. Performance monitoring is going to also be important because, again, with micromobility, there's especially shared micromobility, but also private micromobility. Collecting data is going to be part of the scheme, and then taking that data and using it, analyzing it, and looking at what it's telling us, what needs to be improved upon, and keeping that data in a central location that can also be interfaced with public transportation ridership and other important data, crash data, vehicular data, that it all can all be looked at together to understand how the transportation as a network as a whole works. So those are the policies that we are currently looking at as our suggested policies. We, again, will get more into detail with our questionnaire and some of the questions that you'll have when we go to our discussion. But now I'm going to hand it over to Connor to talk about the design.
Thank you, Chris. And I guess we'll have more discussions in the Q&A session later. And the second presentation, it's regarding QBMP guiding principles. Our presenter, Connor Semler. Connor is a recognized leader in the planning and design of bicycle infrastructure in the US. As a principal planner with Kettleson and Associates, he helped author the NACTO Urban Bikeway Design Guide and the Federal Highway Administration Separated Bike Lane Guide. Please, Connor.
Good afternoon. Thank you so much for having me. It's an honor to be here with this distinguished panel, working with the great presentations that have happened so far. A lot of what I think we're talking about this afternoon was informed by some of the work that was shared earlier today, so it's good to see that that's all coming together. We are approaching the Bicycle Master Plan from the perspective of understanding what are international best practices in planning and designing for people to ride a bicycle or a scooter or other shared other micromobility device. We think about principles because our streets are complicated and it's not possible to prescribe exactly what design is appropriate for every type of facility, for every type of context. And so instead, what we want to do when thinking about principles is understand the needs and experience of people riding bikes and scooters. The principles help us respond to different contexts and different challenges in our streets with the understanding of how someone who's exposed to traffic on a bicycle or on a scooter will get through and that these needs are fundamentally can be different from people walking and different from people driving, and so we need a sort of a third set of expectations. Our guiding principles will help inform the development of design guidelines that will be a part of the QBMP, the Bicycle Master Plan. It will also inform schemes that will move forward into implementation following the plan. And it will help us identify where to prioritize investments in bicycle and micromobility infrastructure based on those needs and those understanding of principles. As Rula mentioned, our work was informed by a lot of existing and really robust planning work that is already underway and taking place here in Qatar. Our work aligns nicely with the principles espoused in the Transportation Master Plan for Qatar and the Guide for Planning Roads. It's also working to fit within existing design guidance from Ashghal and the MOT, like the Highway Design Manual and the Traffic Control Manual. And finally, recognizing that our streets are more than places that we get around. Streets are part of our public space. And so we have looked to learn from more visionary documents like the National Open Space Recreational Facility Strategy, Public Realm Guidelines, and the Urban Design Compendium. Our team is a compilation of people with international experience in best practice in designing and planning for bicycle facilities. And we draw from many of the really wonderful resources around the world, NACTO, Northern Europe, as well as locally context-relevant resources from places like the UAE. All of these materials come together to inform as we sit down and work collaboratively with MOT on developing these design principles. Before I get into the specifics of our principles, I want to just share the framework through which we think about planning and designing for bicycling and micromobility. And the first is recognizing that we are at a place in time when we're trying to align our decision-making, align our priorities differently from how we have in the past. Both the Public Realm Guidelines and the Urban Design Compendium have developed this modal hierarchy, a hierarchy of how we think about our transport modes. And in both cases, they acknowledge that up until now, for many years, we have put the vehicle as the most important mode. Anything that gets in the way of vehicles, makes vehicle driving slower, is minimized to process vehicles as efficiently as possible. But the current understanding really reflects that our job as transport planners and designers is to ensure the safety of all users of the street. And that means starting with the most vulnerable users. And so you can see in different ways that we put people walking, people biking, and on scooters ahead of the needs of people driving. And that's done for the purpose of safety, but it's also because these modes, walking and biking and public transport, serve our many needs much more efficiently than driving does. We can move more people more efficiently outside of a car than we can within. And so it behooves us to try and move our planning framework in that way. The second critical piece of information is that we understand that people have different attitudes and willingness to ride a bike. And what research around the world has shown us, and it was actually repeated earlier today in some of the survey results that Dr. Weil shared, there is a significant interest in bicycling and taking micromobility for transport purposes more often, more frequently than we do today, but that people don't do so because they don't feel safe. And this points to two facts. The first is looking out on the street and not seeing many people on bikes and micromobility is not an indication that there's not a desire. It's that we haven't designed streets that make people feel safe, and we haven't connected those safe facilities broadly enough to provide for that those transport choices. And the second thing is, if we do build our roadway network out with a comprehensive bike lane routing network, we can expect to see those modes shift. Dr. Wells shared that a great percentage of the population would like to use micromobility every day. Those are the people that would start riding bikes and scooters. And I'm optimistic, Dr. Well, that some of those trips would start to come from driving trips if we had a more comprehensive built out network and they could be for more than just leisure. On the right side of the screen, another important principle is recognizing what it is that impacts people's perception and safety on the road. And it really is quite simple. It's how fast is traffic passing me and how many vehicles are passing me. And so we can see from this chart that comes from the US Federal Highway Administration that once we get above, sorry, I apologize for the miles per hour. Once we get above about 50 kilometers per hour or above 7,000 vehicles per day, a fully segregated, fully separated facility is required to provide for that safe and comfortable facility. Our team took a look at the existing street network in Qatar and illustrated what we call level of comfort or level of stress. This is, as it sounds, how comfortable it feels to ride a bike on a street. And the red streets are those that are the least comfortable, the most stressful. And going back to my spectrum of the population, very, very small percentage of the population will feel comfortable riding a bike on those red streets. So you can see we have a lot of work to do, but there's hope. We don't have every street mapped, but a lot of those streets in between the red that are showing up as green and blue and even white are relatively comfortable for people to ride on. And so we can do a combination of building really great big projects, as there are a number of here in Doha, and layering on top a more neighborhood level network while we wait for the rest of the core network to build out. And then finally, on the framework, I want to reiterate that what we're doing here is prioritizing safety. Every agency I've worked with around the world in the US agrees that safety is the top priority. And it's our job as practitioners to advance that need. Safety is the #1 reason that people choose not to bike in Qatar, according to our survey. And most people, the overwhelming majority of people, said that they would be encouraged to start riding if they had facilities to do so. And so we see the trend in the chart that's going in the wrong direction. We're seeing more crashes, more cyclist and pedestrian crashes. As Chris said, as we start to get more people on the road, that might not turn down right away, but over time we do expect that to improve in a significant way. So I'll move now into a discussion of the design principles the draft design principles that we are recommending for the Qatar Bicycle Master Plan. I will breeze past these slides because we've had a good amount of discussion today on different types of devices. A lot of what we heard this morning is in line with where we're moving. Wanting to find that balance between providing people options, designing for the variety of uses that we might expect, while recognizing that heavier and faster vehicles are going to create more of a threat for people, pose more of a challenge. So this is the beginning of the framework that we're thinking through our understanding the different needs and design and physics required for the different modes and how we can plan for that. So our design principles, our guiding principles, are summarized on the slide here. I won't go through all of these in great detail today, but it's reinforcing what I talked about earlier already, that we want to first start with safety, and safety is closely related to comfort. People have a good perception of what is safe and what is not, and designing for those comfortable facilities is going to provide for their safety and invite people to start biking and using scooters and other devices more. We want to plan for directness. More so than people driving, people on bikes and scooters are sensitive to out-of-direction travel because they are using, in most cases, they're using their physical energy to travel from A to B, and they're discouraged if they have to go out of the way, and it may be the difference between deciding to make a trip by biking or not. We want to design our streets to be inclusive and attractive. We want to invite people to come out and spend time in them. We want to make sure that there's continuity. Here in Doha, there are a lot of really wonderful facilities, but when we get to driveways and intersections, it's hard to navigate those as a cyclist. The next step in building out the network, and the reason is it's very difficult, it requires tough trade-offs to provide that safe connection for people biking, and it would maybe impact traffic capacity or be expensive. And so those are difficult challenges that we're trying to overcome, but recognizing that if the facility is not continuous, it may as well not exist for most people. And finally, we want to think about how we integrate biking and micromobility across all of our transport modes. We want to provide a density of infrastructure, both in terms of bike lanes as well as supportive facilities like bike parking and shared micromobility stations. And then finally, we want our network to be widespread. So I'll go through, for the last few minutes of my presentation, these categories here, and I won't dwell on this slide for too long, but these are the categories of how we're thinking about making recommendations for in the QBMP as we move forward. And I'll touch on them each briefly, and then we'll move into a question and answer. So the first is that there are a variety of personal factors that contribute to people's interest and willingness to ride bike or scooters. These can be based on what is the purpose of the trip. If I'm doing a shopping trip and I need to carry a lot of things, I might not be as open to using a bicycle. It can also be how experienced they are and how comfortable they are riding on the street. And of course, there are a number of external cultural and psychological factors that might weigh into someone's decision on whether to ride a bike or scooter. Considering the roadway hierarchy, our thinking on street design has moved away from purely a roadway functional classification system to more of an actual function. So our streets can be thought of simply in 3 dimensions, whether they provide access, they are the way you get from your vehicle, whatever it is, to a destination, to a shop, to your home, to school, to work. If a street's function is for access, then we want those streets to be slow, where people riding bikes and scooters can maybe even ride in the same space as people driving. We're not thinking about moving traffic through access streets quickly because the job of the street is to provide that local connection. Distributor streets, on the other hand, and again, I apologize for the miles per hour. You probably are all used to this. I'm sorry. Distributor streets are their function is to, on the contrary, move vehicles and all modes in longer distances. Distributor streets are sort of the backbone of our transport network, and may need to have higher speeds, will often need to have higher volumes, but they still have an opportunity to be comfortable for people to bike and ride micromobility. Distributor streets, unlike access streets, should not have lots of driveways and should not have lots of turning movements across multiple modes, multiple lanes of travel. And so when we think about separating these two, we remove a lot of those conflicts. Most of our crashes happen with vehicles turning across our walking and biking paths. And so as we get to a difficult street, we need to decide what its function is and then design in that direction and not continue to try to do both things, because that's where we have our most dangerous streets. The street's function also is informed, of course, by land use around it, the planning context. We are embracing this functional classification recognition that is built on how land use informs the likelihood of having short vehicle trips, or short trips of all kinds, which can be best accommodated by walking, biking, micromobility. The types of micromobility trips that we want, the types of trips we want to serve will be informed by land uses. And often the urban, commercial, suburban, minor collector types of contexts are the most challenging. We have a density of destinations in these contexts, but we also have a high reliance on driving. And so we want to, where possible, create that space to allow those shorter trips to happen outside of driving, which can reduce traffic, improve safety, and improve accessibility for all people. As we think about prioritizing investments throughout the nation, throughout the state, we want to think about where we're likely to see the greatest demand for biking and micromobility. And the QBMP approach to understanding where that demand exists comes from understanding the characteristics of the place. So what I'm showing on the screen here is an early draft of what we're calling potential for short trip demand map, which uses inputs on the screen here, presence of public transport, land uses that draw short trips, things like schools and shops, and equity considerations. And these are put into an equation that helps us predict where those short trips are likely, and then using that information, recognize that we can convert those short trips to bicycling and micromobility with the appropriate infrastructure. It's really, as I said already, it's critical that we think about how our bicycle micromobility network interacts with other modes, other transport modes, and especially with public transport. As we saw in Austria, that relationship between the access to the transport network and the transport network, the public transport network itself is a really critical link, and we have bicycling and micromobility have an enormous potential to help make that connection, and even outside our most urban areas. So we want to think, as we're moving into the plan, about things like neighborhood mobility hubs, where all of the public transport comes together. There's a bike shared micromobility station with the public transport station, with maybe other shared mobility services like Uber and Lyft. Bring those things to one place and provide amenities and accommodation for those interactions. Next, we are thinking about our overall network and those destinations that we want to serve. We want to design facilities that provide that legible, continuous network that allow people to travel from wherever they're going to wherever they're going, and knowing confidently that there will be a route. And over time, they won't have to memorize this very specific trip, but they can expect that they're going to come across multiple options, just as we do with driving. How many of you get out to start your trip from here down to West Bay and check your map and have 4 or 5 different options you might take depending on what traffic is doing today at that moment? We want to provide that same kind of level of choice and flexibility for people on bikes and scooters. And then also recognizing that a lot of the streets here carry a lot of traffic and are built out to the edge of the right-of-way. There's not room to expand many of our streets, at least in the central part of Doha. How can we be creative to make those connections? I talked earlier about the neighborhood streets that are already relatively low stress. We can perhaps bridge some of those gaps on neighborhood streets and then focus on providing the highest quality crossing across the busy street that we can. Apologies for the formatting on this slide, but just wanted to share quickly how we're thinking about the spectrum of bicycle and micromobility facilities. Starting on the far left side with shared streets that are low volume, low speed streets already where people can bike comfortably. And then moving to the right as we get increasingly separated from traffic, recognizing that comfort issue that we talked about already. Intersections are the trickiest thing to solve, always, everywhere, not just here. And so what we want to do is think about how we can move towards prioritizing biking and micromobility modes through intersections in an acknowledgement that these are the most dangerous, most stressful part of someone's journey. So identifying, we have a toolkit of strategies we're developing in the design guidelines for raising the visibility and awareness and legibility of these intersections, so that when we have those conflict points between people driving and people on bikes and scooters, it's clearly communicated who has priority when, and how we get people through safely to the next leg. I talked a lot already about corridors, streets, but we also, the QBMP will also spend a good deal of energy thinking about supportive infrastructure, by which I mean things like shared mobility systems, stations, bike parking, shading, the types of amenities that make using a bicycle or a scooter here attractive and convenient. Earlier today, we saw, I think from Dr. Takeru's presentation, we saw a recommendation on how the density of shared micromobility stations, something like 200, 300 meters, that's a very dense coverage and will require a significant investment. At the same time, that's what would be needed to to create a service that is accessible to all. So thinking about those trade-offs as we go forward, and then of course, good quality bicycle parking in convenient locations, visible, accessible. We'll make recommendations across these measures. Finally, we want to ensure that while we are upgrading our streets for biking and micromobility, we are not only designing for people with disabilities, people with mobility challenges, but in fact, enhancing their experience by creating further separation from traffic, making our intersections more legible and more intuitive. And so the QBMP will include recommendations to address this as well. And with that, I wrap up. Thank you.
Thank you, Connor. And I guess to be on time, we'll go directly for the Q&A session and we'll have some discussions. I'd like to invite my colleagues, Chris and Connor, and per Dr. Wael instructions, just sit under your photo. اوكي بس معلش قبل ما نبلش احنا رح نوزع هلا حاليا استبيان بخصوص السياسات المقترحه ولانه رايكم بهمنا نتمنى انكم تعبوا الاستبيان موجود باللغه العربيه وباللغه الانجليزيه ففيل فري انكم تختاروا النموذج اللي بيناسبكم ونتأكد إنه سلمنا الاستبيان مع نهاية السيشن. We've designed a questionnaire regarding the policies. Just feel free, it's designed both in Arabic and English language. Please just read it and you can click on